And welcome to the third and final themed webinar for to support the Future Flight competition, phase 2 of the Future Flight competition. Today's theme is regulation. The aim of the events, of all the three events, is to sort of inform you and enable you to find new collaborations for phase 2 of the competition. And to aid that, you please do use the chat function in YouTube, and let's get the conversation started. Introduce yourself, talk about what you're working on and what you might be looking for. My colleague Simon is helping on the chat function, and during the Q&A session, we will pose all the questions that you have for the speakers at that point in time. So please do feel free to pose questions for the speakers as we go along. So we are live on YouTube, and this means that this event and all the other Future Flight events are stored there for anybody to go and view at any point. Today we've got again some good speakers in the context of regulation. So we'll start off with Gary and then work through HSC, CAA, BSI. We've got Chris Reed and also Drone Prep to give some regulatory overviews on various aspects, and then we'll go into the Q&A, and then yet again we'll have the 2-minute pitch presentations for you, and then those of you that have scheduled meetings, you'll be able to start those at 1:30 later on. So it's really good again that you can join us today, and yes, with the slight variations in the agenda due to the usual challenges that we are currently facing at the moment. So it's really pleased that we're seeing really good numbers registering for these events, and I know we get a lot more coming on to YouTube. It's good that that passion and that enthusiasm for Future Flight is still remaining during this challenging time, and I wish all those that are affected, experiencing all those severe challenges and are not feeling particularly well right now, a speedy recovery, and wish you all well. So to get the event up and running, I'm just going to pass over to Gary Cutts, who's the Challenge Director for Future Flight. So when you're ready, Gary.
Fantastic, and thank you again, Michelle. It's great, as I was saying before we start, it's great to be back for the third of this series. The first two have gone, we think, exceptionally well. It's really good to get people on board and keep talking to us about Future Flight. So firstly, I don't think I've quite got control yet. There we go, thank you. So I will start with a thank you to you all, and I suppose a slight apology. It's entirely possible because we've got different themes of all these networking events. The number of people have been to all of them. That's fantastic. The one downside, I guess, is you get to hear me say largely the same things 3 times, so it's coming again. But I will start with a thank you to all of you, those who've been multiple times or here for the first time today. As Michelle said, we really appreciate people making time to continue to engage with Future Flight. We had a large number of people at the first and second event. I'm sure there'll be a significant number again today. We know your time's precious and you have lots of distractions right now. So it is fantastic that people keep engaged with this challenge. Of course, it's really good for us. We're trying to keep this community going. We're pleased, if you like, for the programme that you're engaged. But also I think it's really important that industry shows its appetite to continue to engage and continue to drive the pace of these innovative developments. The more that people keep turning up, the more the message is understood in government that industry is ready to go. So thank you for your attention today. I'm going to start with just a little bit of update of where we are in the challenge, then run through a couple of slides to just reframe the challenge for anyone who's become disconnected to it, and then talk about what the next stages are. So our kind of transactional update, if you like, by this point in time, we'd expected to have had our first significant competition in phase 2 open and people being able to bid. We had to slide that, the phase 2 competition, back by approximately 1 month. That was driven entirely by operational considerations in UK research and innovation. I mean, 3 dimensions to that. The dominant one is that we are running a large number of competitions directly associated with COVID-19 across a range of fronts, everything from vaccines manufacturing through to the ventilator challenge. So the team has had a number of new and clearly urgent competitions to deal with. Secondly, for the competitions we've already been running, and there are always hundreds in flight at any point in time, we've had to do a lot of change management. The world looks quite different now as a result of COVID-19. And lastly, of course, we're now operationally challenged. Everyone is working remotely, and we'll have our own issues of people's availability. So for all of that, we had to take a practical decision to move a number of competitions back. Absolutely can't guarantee that there aren't further disruptions in operations, but we're trying our very best to hold that 1 month and still get Future Flight up and running as soon as we can. We've shared the dates for phase 2 via the KTN, and we will continue to share them when they're firmed up and via media platforms. I think the key thing is to get ready for those intending to bid, and be ready to do that from early to mid-May. And we intend to hold the competition period open still about 7 weeks. So it's still relatively short. My encouragement would be, it is a consortium-based competition. We continue to look for people working with others, ideally working with others who are giving some breadth to the consortium, and therefore people you may not have worked with before. So the real thinking that needs to go on at this stage is to be building the consortia and be as ready to go as you can when the competition gets going. So backing up a little bit and just kind of reminding ourselves what Future Flight was, we talk a lot about it being the third revolution of aviation. I don't think that's too grand. The first revolution being getting us airborne back about 116 years ago. Next one was the advent of jet age, if you like, but getting us to long haul and mass transit with very efficient aircraft, which actually kicked in, I would say, from kind of the early to mid-50s we started that journey. It's quite a long time ago. It's fantastical. So our third revolution is much more flexing the way we fly, looking at different classes and types of vehicle that give us all kinds of aviation flexibility in moving goods, people, and provision of services. And that's very much what Future Flight is about. So for the breadth of the challenge itself, we know that a lot of attention always goes in new things aviation onto the vehicles. They tend to be the most visible part of any aviation system. But we would contend that although there's a real technical challenge in developing the new vehicles that we conceive of in Future Flight, that the vehicles themselves are kind of well taken care of. There are a number of companies and organisations working them. There's plenty of support. There's plenty of government interest in the vehicles, and we think the vehicles will arrive. Our contention is that the aviation system, to accept and make best use of those new classes of vehicle, that's a fundamental far-reaching change in a very integrated system. And Future Flight is all about encouraging the change in that total aviation system. So I'm just going to walk around the chart in a few minutes. So firstly, if we talk about the kind of the vehicle part themselves, there are a number of classes of new vehicle which are emerging. We'll talk about just 3 here, but there are more. So I'll start with the smallest one, drones. And here I'm thinking more like industrial drones than personal use, hobby type drones. These drones are substantial, can provide meaningful missions, everything from transport of goods right through to a range of services, surveying, maintenance, and so on. Those drones clearly exist today. We know that there are many companies providing them, many sophisticated companies. And although every week I read a new news story telling me that somebody has pioneered a slightly more advanced use case, we're moving to some of the more sophisticated operations, bulk, those vehicles are still prevented from realizing their potential because of the lack of a total system. And that's everything from an air traffic management system, the regulation that allows them to routinely fly beyond visual line of sight, right down to some of the infrastructure elements. And we'll talk a lot later about social acceptance. So the systems that allow drones to fly require development. If we come to the second class of vehicle, air mobility vehicles, here we tend to think of something like a 3 to 5 person people moving vehicle. In our world, certainly a zero carbon source of power, quite possibly battery electric powered, could be hydrogen fuel cell or other sources of power such as hydrogen itself or propulsion, but a new class of vehicle. For those, people conceive many missions. A lot of talk is about urban air mobility. So that's your crudely is your air taxi model, picking people up in dense cities, moving them across the city to different places, dropping them down. We think there are some equally valid use cases of moving people in and out of cities or between urban regions, so it becomes a kind of sub-regional people mover. Next case we find really interesting is this concept of difficult to connect places. So here in the UK, we could be talking the Highlands and Islands of Scotland, some of the places perhaps in rural Wales or elsewhere. Internationally, there are many regions where it's difficult to connect people. So the concept of rural air mobility is also of interest to us. So that class of vehicle, it's not quite here in the same way drones are. But if you're not close to this, go research it. You'll find a number of people have flown prototypes and will be flying more this year. There are more than 200 companies developing such air mobility vehicles. But again, we would say that the total infrastructure to allow them to maximise their potential is not in place, and parts of it are planned, but not the totality of it. And I'll come back to some of the examples there. And the last class of vehicle for us is this sub-regional aircraft. So here we're talking more like a classic looking aircraft, perhaps more in your 19 up to say 40-seater, where we change the propulsion mechanism so that it's going to low carbon. And at a level you think, well, that sounds mainly like an aircraft kind of challenge. But if you think about that propulsion going to say more electric, what is the infrastructure and the requirements to do the charging? How do you do that? If it goes to hydrogen, again, how do you deal with hydrogen, the health and safety aspects, the regulation, and just the provision side. So even for something that looks like a more classic aircraft, infrastructure requirements could be quite significant. But for future flight, we foresee a world in which all of those classes of vehicle and others will become much more prevalent. So we imagine an aviation system where we're saying drones, air mobility, freight carrying significant drones, smaller sub-regional new class of electric vehicle, fully integrated with today's aviation system of large passenger transport, military operations, general aviation, helicopters and the like. So creating a new aviation system that can cope with all of those aspects together is a challenge. So a quick walk around some of the aspects of the challenge for us. So let me start top left on this slide, control and regulation. You're about to hear from David Tate and others on regulation. Regulation and the rules that go with that are the theme of today's presentations. But for us, there's obviously development in regulation required. But going hand in hand with that are the air traffic management solutions. So today's air traffic management in several places, and certainly in the southeast of the UK, is pretty much at max capacity. And depending on how you look at it, the underlying technology of air traffic management is either 1940s or 1960s level of technology. So our vision to put lots of new classes of quite different types of vehicles into that airspace, perhaps flying much closer together and close to urban, densely populated regions, that's a real challenge to air traffic management, and a new system is required. The air traffic management system completely hand in hand linked to the regulation of operations that goes with it. They've talked about infrastructure. I covered a couple of these as examples, but the physical infrastructure for these new classes of vehicles, that needs to be imagined, designed and realised. At our last presentation, worth looking at it online if you hadn't seen it last week, we talked about infrastructure, and under the infrastructure, some really interesting concepts of what an urban airport would look like if you're flying urban air mobility. So when you put several vehicles landing atop a building, what's the physical concept that allows you to do that? What are the systems required to have in place? How do you deal with charging, fireworthiness and everything else? There's a real infrastructure problem. Then you come to the underpinning digital infrastructure. What are the systems, the data standards and protocols that allows all of these vehicles and the operational system for air mobility and beyond to talk to each other? So there's a huge data infrastructure piece there. And then lastly, this concept of operating models. What is the basic concept of operation of this? How on earth does an on-demand air passenger service work? How does it integrate with scheduled aviation? What are the business entities that will come to pass? And also wrapped up in new operating models, this concept of social good and social acceptance. Now, how do we take the public with us so that we don't just reluctantly accept that this new technology is going to get pushed upon them, but more and more people see that we're doing good social things as well as economic things by introducing new classes of vehicle. So for us, future flight is that entire aviation system. It is the vehicles are part of it, but it's not a vehicle program, it's an aviation system program. The second really important point for us is we see it as being completely interdependent and integrated together, and therefore you can't carve up requirements for each bit of this, let a part of the industry just go and come up with a solution and come back. Clearly, the physical infrastructure concepts become completely linked to the regulation, which is utterly linked to the air traffic management. The vehicles have to anticipate things like the air traffic management and be designed in concert with the physical infrastructure that they will get. They're right down to what are the initial use cases. They will have a huge influence on the public perception of the challenge. So for us, the whole thing is integrated, and that's why it is being driven as a set of competitions where we're looking for consortia to bid, and ideally consortia that cross some of those boundaries and look at some of the interdependencies. So that's everything that we're doing in Future Flight, as a reminder. So if we just talk about the phasing and the timing of the challenge now. So we'd said very early on that the challenge is not deterministic. We don't know what the end point will be. We are creating new markets. We're creating a radical range of new technology and integrating them together, so the shape will evolve. So we've always had this concept of engaging with a wide number of stakeholders early on in the discovery of concepts phase, bringing people together. Our next phase of development is where we're trying to pull people into formal consortia, developing innovations and ideas for parts of this total aviation system. By the time we get to phase 3, we imagine that we'll have pulled into a smaller number, but possibly larger consortia, where we'll be encouraging people to merge together and more have the whole system in the bounds of one of the consortium, with a view that we have a final demonstration of a flying system with 3 classes of vehicle flying in what we always say is meaningful, challenging, real-life use cases in the same airspace by 23, 24. So that's the shape of the challenge. So just a little bit about some of the content and where we are with the next phase. We had a set of workshops in Birmingham that I know several of you were at, many names online that I recognise here. We thought they were a really good set of workshops hosted by KTN. And what they were intended to do was a couple of things really. One was to give us as a challenge team a better understanding of the total landscape of future flight, but also to get everybody in the room having that landscape view of it. So if you're a vehicle manufacturer, fully understanding perhaps the not just the vehicle regulation, but also the flight operations issues. I see Chris Reed online. Chris and I talked a little bit about the liability, the legal implications and so on. So what we were trying to do was give people this wider view and help inform us. Secondly, we were explicitly trying to build consortia, so get people to work out what partners they needed and how to partner with them, so that when we get to phase 2, we go ahead and we're already got consortia good to go. So what we found from those workshops in terms of the content was really important. So we've put a number of research themes for phase 2 down. There will be some more people could do. So if I quickly walk down these, and I've covered several of them in my introduction. So first, the concept of new modes of air traffic management, unmanned traffic management systems. How do they integrate together? How do they integrate with today's aviation systems? Both the physical and the underpinning digital infrastructure systems, how they come together. I didn't talk so much about this today, but the concept of autonomy. Many of us believe that some of our visions of the future will only come to pass if we have a different degree of autonomy to today. Those technologies are moving on at pace. So what are the autonomy solutions? How do we develop them with the same level of safety as today's aviation system? How do we get the public interested in accepting of autonomous solutions? Then we get the digital and communication systems. Absolutely robust, completely standardized communication is really important across this. What are the new business models we'll put in place? We won't drive them as government, but we'd like to understand them and make sure that we're producing things that are ultimately usable by business. We covered a little bit earlier the public acceptance challenge. That's significant. A number of players would say that might be the final hurdle for this new aviation model. We can perhaps overcome all the technical solutions, but you have to let people want to let us do this and not see it as tech being pushed into their lives. Possibility of doing transport integration, intermodal, multimodal transport. How does that stuff link together? We're also interested in simulation. We are absolutely going to do aviation system demonstration in future flight, and people are already doing flying demonstrations. But ultimately, we have to show this system can scale up at volume. Simulation is likely to be an important piece in doing that, to show we can take individual demonstrations and know how they would work in a much greater volume. Then what we call the non-aerospace regulation, and only that aerospace regulation is kind of obvious, so it's not explicitly put down here. So this is the first bit where I'll just link to today's theme in detail. So I've learnt quite a lot in the last year about the regulations that will need to come to pass that are not aviation. I absolutely know I don't know what they all are yet. We're evolving some of these types of things. So a few examples. So definitely you can imagine a world of pure ground-based health and safety, of dealing with high voltage electricity, rapid charging. How do you deal with hydrogen? What is the health and safety concept of creating a vertiport atop a tall building? Then you get that itself, the building. There must be a whole set of regulations, which to me are building regulations around the standards that are required for that. Perhaps there are also other regulations around things like communications. Now, this week we had some interesting conversations with the British Standards Institute, BSI, and that's kind of opened our eyes to there are things as well in the standards regime that aren't pure regulation. How do we encourage industry to quickly come up with some ideally global standards so that the industry doesn't keep reinventing the wheel and create systems which cannot knit together? So what are the underlying standards that aren't regulation per se? So there's quite a big theme here as we're creating new markets and new innovations of how do we do that in concert with the regulations and standards and influence them. And then lastly, the use cases. So we absolutely expect to see people come into the consortia who've got real challenging use cases. And then lastly, these total security systems. So for us, there will be other things. No matter how we construct our challenges and competitions, we can't make them exhaustive. We're trying to signpost the things we know are interesting, but there will be others. So we're always receptive to adjacent or other themes. You may have a consortium that's tackling one of those or something you think we should be considering, and please just get that submission into it. We're very receptive to this being a broad challenge. Lastly, our workshops, as well as the things that are directly linked to creating flying demonstrations, we said there are also some underpinning capabilities that we're happy to support. They include things like creating a UK-wide network of physical and virtual test facilities, so we can prototype the entire system behaviour with multiple integrated facilities. We talked a little bit about this before, but a basic data infrastructure that allows the participants in this emerging industry to talk to each other with a set of standards. And that links nicely to this concept of digital twins. So lots of definition of digital twin, but we absolutely mean a system-wide predictive through-life simulation that lets us model and understand the interactions and work out what the right solutions are. So creating a digital twin of an operational aviation system, boy, is that a big challenge. So we're receptive to people coming and talking to us about that as opportunities. So that's where we are. We absolutely want people to come in to consortia. And because it's an industrial strategy challenge fund, it has to be industry led. That's just one of the guiding rules, but anyone else could take part with the usual rules about nationality and UK based and so on. So that's a quick trawl through Future Flight. As I said, this is the third of a sequence of really useful networking events. Today is about regulation, and I would just encourage us to have the most open-minded view of what regulation is. We'll all learn a lot listening to today. It is aviation, aerospace regulation, a whole range of other regulation elements around that for the total system, but also this concept of underpinning standards as well. How do we interface with these and make sure we develop things that ultimately are usable in a way that gives us an aviation system as safe as today's large aircraft aviation system. So thanks again. We appreciate your time today. Please have a fruitful event and engage fully. Thank you.
That's great. Thank you, Gary. And before anybody starts posting questions, KTN will circulate the details of the competition when they are live on the UKRI website. So we will be sending out an email for you, so no problems there. Okay, so now we're going to progress on to Charles Oakley, who's Head of Business Strategy at the Health and Safety Executive. So when you're ready, Charles.
Thank you, and good morning, everybody. Yes, my name is Charles Oakley. I'm actually, unfortunately, standing in for a colleague of mine, Dr. Stuart Hawksworth, who was planning to give this presentation, but unfortunately has gone down with coronavirus. So I'm taking his place today. So first of all, I should just say why I'm speaking here on behalf of HSE. Many of you will be familiar with HSE's activities in regulating the workplace from a safety perspective and health. And you'll be familiar with HSE's regulatory function and policy function. You may be less aware that HSE has its own science division, and that's the part of the organisation that myself and Stuart work in. The science division carries out research, accident investigation, and other purely scientific activities to create the evidence base upon which HSE's regulatory and policy activities are based. And that's one of the fundamental principles for HSE, is everything being firmly evidence-based. Most of the work takes place at a site in the Peak District in Buxton, Derbyshire, where we have got extensive experimental capabilities, and the majority of our 350 odd scientists and engineers work. So just wanted to make that clear that I'm representing our scientific activities rather than our regulatory duties, although clearly HSE's regulatory responsibilities do cover some of the aviation side. We work alongside Civil Aviation Authority, and we would regulate the ground-based infrastructure side of things, which we'll perhaps come back to. So first of all, I just want to expand on that a little bit in terms of our, where HSE fits in the cycle that we work within. So particularly when we're looking forward at new technologies and innovations, before they've really come onto HSE's regulatory radar, as a science division, we're looking ahead to inform HSE of what might be coming in the future, so that when it becomes widespread and implemented, HSE is in a position to regulate those innovations effectively and from a position of knowledge. So we look ahead, we anticipate new challenges, we have a foresight team, and they look at what's coming up. We then look to provide the evidence to ensure that the resulting risks from these technologies are understood and can be effectively controlled. This work then clearly goes on to underpin operational policy activities with a view to protecting workers and engaging with others. As an example, we're firmly involved in the government's move to start space operations from the UK. So we are involved in this cycle. We are, on the one hand, informing how we would help with the regulation, but on the other hand, we're carrying out scientific research to fill the knowledge gaps which are needed in this area. So it's all about generating evidence to underpin regulation, policy, standards, and so on that would come through, which of course is essential for safe introduction and operation of new technologies. What I want to talk about particularly this morning is future energy, and I'll tell you about our work that we've been doing already on things like hydrogen and batteries, which have already been mentioned. So it's specifically in those areas where I think we have something to bring to the party based on that background knowledge of understanding clearly regulation and regulatory needs. I think we often come into this because a lot of the research, particularly early TRL research, is focused on proving new technologies in terms of delivering benefits, economic benefits, environmental benefits. And as HSE, what we don't want to do is to delay or hinder the realization of those benefits because the safety considerations haven't been considered. And that's historically what has tended to happen. So we're very keen to be involved very early in these areas, these projects, so that safety is considered, and health, of course, considered early in the process and doesn't become a hindrance further downstream. So moving on, what we can offer in this space is research, development, consultancy, but particularly with that focus on safety, which brings in resilience, reliability of systems, in order we can assure everyone involved, whether that's the public, workers, employers, businesses, that they have a safe and reliable system as they introduce these technologies. I'm going to begin to focus a bit more on hydrogen and batteries now. We are internationally recognised in this space. So Stuart, who is supposed to be giving this talk, is the president of the International Hydrogen Safety Panel, a global body ensuring that as we develop the hydrogen economy, it is safe to do so, and that covers everything from generation, transport on a global scale, and implementation on a regional scale. And the same for battery technologies, which carries its own different types of risks. Strong international links through that. We do a lot of work on EC projects and represent the UK government. And of the 350 odd scientists working in science division, roughly 100 or just over 100 are working on these major hazards, major risks, future energy type issues. So there's a strong body of expertise there, which we would love to see involved in the kind of programs we're talking about here. So if we take a look at the overall energy landscape, we're working across all of this, these areas. So in transport, road transport, rail particularly, are moving quite quickly, particularly in terms of hydrogen as a potential fuel source, energy source. We've been working in this area for probably knocking on 10 years now. So we are looking at refueling issues, which, and some of the learning from that will be clearly transferable to the aviation sector. I'll talk a bit more about hydrogen spills, which is a particular issue. While not necessarily relevant to aviation, for instance, we are looking at, for instance, at what would the consequences be of an accident in a tunnel, be that road or rail, where clearly the consequences and the way of handling an accident where vehicles have hydrogen on board would be quite different to our current situation. So this is really about trying to anticipate issues, to understand them, understand the science, understand the practicality, which can then inform appropriate regulation, and particularly not make sure we don't have overburdensome regulation that is based on knowledge and evidence. We're looking at hydrogen, the hydrogen infrastructure, the hydrogen utility networks for domestic supplies. We're looking at introduction. We've already worked towards introduction of 20% hydrogen in the domestic supply. We're looking at 100% hydrogen and the implications of that on the existing infrastructure network and on what that means for domestic appliances. So we're looking at both inside the house and the distribution network. A lot of work going on in that space, working with a number of consortia there with experimental facilities on our site. And then looking also at things on industrial commercial scale, so hydrogen as a fuel source for generation of power and so on. Just a bit of a sideline, you may be interested that we have a gas turbine running on hydrogen on our site at the moment for power generation at the moment, but understanding the fault conditions that come with that, the implications, so that as that gets scaled up, it's coming from a position of knowledge and evidence of the safety implications of that. So I think much of what we are already doing immediately has an application into future flight in terms of the infrastructure that Gary mentioned, refueling issues, let alone some of that knowledge transferring directly to the aviation side. But I think a lot of this will be applicable to the areas that have been mentioned. So in terms of what we can do, so we bring that expertise, that capability, testing, certification, and so on of aviation energy systems. A lot of transferable knowledge there. We do a lot of work, pre-normative work that sits behind the development of standards and regulation. That's kind of what we do as a day job, but it's now coming from this position of knowledge on these future fuels. I've mentioned the testing of gas turbine operations, but we're also looking at liquid hydrogen systems, large-scale battery facilities, and can support strategic projects as we would like to do as part of this Innovate program. Just as an example, looking at liquid hydrogen, and this I think demonstrates the importance of these considerations. So this is an EU project called Presley High. You can look up the acronym, find out more about it. But it's understanding liquid hydrogen spills, clearly cryogenic temperatures, and what we're carrying out these spills on site and discovering new phenomena that haven't been observed before, new science that we're endeavouring to understand, which needs to be done if these things are going to be introduced into the transport sector, or where liquid hydrogen may be a way of either transporting or storing fuel. And still there are many knowledge gaps in this area which we're endeavouring to fill. And without understanding the phenomena we're observing, being able to account for them, we won't be able to regulate them. And without being able to regulate them, we won't be able to provide assurance to the society, really, that this is a safe fuel to use. It's all solvable, it's all doable, but there's still a lot of groundwork that needs to be covered in these kind of areas, and that's what we're doing at the moment. The same all applies to batteries. We look at the whole life cycle of batteries, and this will be relevant to some of the systems that Gary described. A lot of work, again, going on already taking place in terms of proving battery power as a viable energy source for flight. But we look at the associated issues, and as an example, these cells can develop faults, but these cells can be in close proximity to others, and the fault can propagate throughout a battery pack. But then if you think of large-scale manufacture and transport of batteries, if you can just visualize for a moment a warehouse full of battery cells, which if it's not properly managed and regulated, a fault in just one of these cells can potentially cause a catastrophic situation in that warehouse. And these issues aren't yet fully understood in terms of how that propagation can take place, and therefore how they can be mitigated, how emergency situations can be managed. And of course, what we want to avoid is an undermining confidence in these, in this case, new energy systems, due to one major disaster. It can happen very quickly, and we want to make sure that the benefits of these systems are realised and aren't undermined by something going wrong, and that's where we're coming from. So from our perspective, we really like to be involved in these programs, so we're looking for partners who can make use of that capability, that experience that we have already developed, can make use of the testing facilities. These are high energy, potentially difficult tests. Of course, as you might expect, being HSE, we have quite a lot of experience in managing those tests safely and be able to carry them out in a safe environment. Particularly looking in those early TRL space to take ideas from bench scale through to kind of to scale up. A couple of things to kind of add into that we can perhaps uniquely bring. So it's bringing all that experience, but with a firm eye on regulatory applications. Clearly, HSE is a regulator, and all of our science is carried out in that context. So it's carrying out the research, but within a regulatory context and with a view to that application. Probably the focus off that list that Gary mentioned, probably the greatest application to physical infrastructure, clearly public acceptance by providing reassurance, and clearly the non-aerospace regulation, I think, is where we can particularly come in, and testing. Just a little free fact for you is that our site in Buxton, we believe, is the only civilian site that has a no-fly zone. So offhand, I can't remember what altitude that goes up to, but we do have a no-fly zone over the Buxton site. So that may be of interest to those wanting to test systems in a safe environment. Right, running out of time now, so I'm going to quickly cover just one other area, which is around our work on data and information. So as HSE, we collate an awful lot of information from accidents. There's some figures there. And what we're working on at the moment is bringing, while we keep all that data and have it stored over the last 40 years or so, is to be able to synthesize that and turn that into a form of usable intelligence. And we should not disregard the importance of learning from the past in terms of informing future technologies. And so while this past experience clearly will have very little in terms of hydrogen or other new technologies, the underpinning reasons for things going wrong remain the same. And we're looking at pulling that together. It's helped significantly by an award of a £10 million programme, a grant we've won from Lloyd's Register Foundation to develop this on a global basis. And so we're now bringing our own data together with that from other parties, industry and other areas around the world to form a knowledge base that can be used to inform programs such as future flight, so that we don't repeat mistakes made in the past at a fundamental level. So this can all tie in and help programs. So that's where I'd like to finish, I think. So thank you for that. That's our site in Buxton. Always worth a visit. And we'd be delighted to hear from anybody who might think we might be able to help their consortia as they consider applying for this programme. So with that, I think I'll hand back to you, Michelle.
Okay, that's great. Thank you, Charles. If you want to get connected with Charles, please do let us know at KTN. Myself or Simon can help with that, or we've got the Future Flight email. Some interesting aspects in there that might be of use to you. So yes, and any questions, please put them in the chat function. But in the interest of time, let's move straight on now. David Tate, who's Acting Head of Innovation at CAA. So when you're ready, David, thank you.
Thanks, Michelle. Can I just check first of all that everyone can hear me?
Yes, we can hear you, David.
Great. Okay. Thanks, everyone. I'm, as Michelle said, David Tate from the Civil Aviation Authority, where I'm the Acting Head of Innovation. As I'm sure you all know, the CAA is the safety and economic and security regulator for aviation in the UK. We are a statutory entity, and we exercise the legal responsibilities that the UK has to ensure the integrity and safety of the aviation sector. I specifically sit within the Innovation Hub, and we are providing the frontline engagement with the Future Flight programme. We've been working very closely with Gary and his team over the last 6 months to bottom out exactly what our role in this project is going to be. And I'm going to first of all give you an introduction to the Innovation Hub and how we work, looking particularly at our regulatory lab and Sandbox, the regulatory incubator model that we've developed over the last year, and then talk briefly about how this aligns to the Future Flight Challenge. I'll kick off by saying that the CAA has been recognised as a key enabler of future flight. It is going to be necessary on any analysis for there to be some form of safety and regulatory approval, whether that's an entirely new safety and regulatory approval or an extension of an existing permission, that for the CAA to become involved in almost all of the consortia in almost every conceivable way as future flight progresses. And I think one of the important things to point out, pick up on something that Gary said, that it may not straightforwardly just be safety approvals that you're looking for from us. It may well be clarity on the regulatory frameworks around security, around the future potential economic and business models, and it may even be things like where the CAA plays a role, for example, as a statutory consultee in planning and building applications that are made to local authorities. There may also be a role for the CAA in helping to get other regulators involved in this discussion, and we're happy to play that role as well. We've got strong relationships with the HSE, as Charles said, with Ofcom, and with the Information Commissioner's Office, all of whom may well have a role depending on the types of technologies that consortia are proposing to take forward. So the Innovation Hub, which is my team, has been up and running for a year now. and we provide the CAA's strategic response to innovation and new trends in technology and business models. The genesis for this was that the CAA's board recognised that we were becoming increasingly asked to respond to projects which had very short development cycles, in which new entities were entering the aviation sector, perhaps for the first time. We had strong relationships with market incumbents, but often we were talking about developers of new technologies coming from markets like the financial services sector or the software development sector and didn't have previous aviation experience. They often struggled to engage with us as a regulator, sometimes not quite understanding the purpose of a regulator in this sector, having not necessarily dealt with one before. And so there was a recognition that we had to do things differently, and to there was a role for an interlocutor within the CAA who could speak the language of industry and also of regulators. So what's on this slide is a depiction of the various stakeholders that we as the Innovation Hub interact with. Internally, it's our Safety and Aviation Regulation Group, our Aviation Security Group. We sit within the strategy and policy team, so we're very much a central corporate function within the CAA with a cross-cutting responsibility. And we work very closely with our colleagues in the CAA International to utilise our policy and regulatory experience at an international level, so tapping into ICAO, previously into EUROCAI, but into EASA, but continuing to have a role in, for example, EUROCAI, in setting new policy and standards and frameworks at an international level. We're also work very closely with HMG, particularly with the Department for Transport, but also with BAYS, who originally funded the establishment of the Innovation Hub through the regulator's Pioneer Fund, as well as the Department for International Trade, DFID, the FCO, Home Office, and Cabinet Office as required. So effectively, the Innovation Hub provides a one-stop shop for all the engagement the CAA needs there. And picked out, obviously, on this slide is the Future Flight Programme, which I'll be talking through in a bit more detail. So the mission of the Innovation Hub and our challenge from the CAA board is to create an environment in which innovation in aviation can flourish in line with our principles. Those principles are safety, security, and consumer protection. In developing the service, we've developed essentially 4 arms to the Innovation Hub. The 3 of these are frontline services that I'll talk you through in a moment, and the 4th is our business ops team, which provides the governance and structure which makes us effective in delivering the work that we do. And that's very important in terms of providing the continuity and program management that's going to be needed for the Future Flight Challenge. So the first of the services we've established is our gateway service. That's primarily accessed through our website, but we've got web forms, guides to all of the various, our regulatory toolkit, which are written in plain English and designed to be accessible to new innovators coming into the market. We picked up on feedback that the CAA was viewed as being quite monolithic, that if you didn't know which part of the business to engage with, you had to go round the houses, that there wasn't necessarily an end-to-end customer service, that if you dealt with one part of the CAA but required a permission from another part, it was often quite difficult to move between and within teams. And that's where our gateway service is designed to improve all of that. The second service is our regulatory sandbox. I'm going to talk a lot of detail about that. That's effectively the methodology that we've developed to partner more closely with industry, but in the exploration and testing of their technologies to enhance the regulatory readiness of those proposals as they work towards getting a formal regulatory approval. So it's about improving that regulatory readiness, and I'm going to go into that in quite a lot of detail in a minute. And the third is our regulatory lab. This is our capacity to rapidly prototype new regulations, frameworks, and policy responses. The intention is to anticipate and respond to the complexities that are generated by your new technologies and proposals, and to recognise that we have lengthy legislative development timetables and regulatory development timetables that often struggle to keep up with new technologies coming out, and therefore we as the CAA need to at least start giving industry forward guidance as to where the direction of regulation is going to go. There will be caveats around that. We can't guarantee everything, but what we want to do is give you the best possible steer of what our thinking is at a particular point, and to give you access to our best thinking on these topics. So focusing first of all on the regulatory lab, what I've provided on the screen is a list of the existing guidance, activities and regulatory developments that may well be applicable to future flight consortia. We've focused on key trends, future air mobility, UTM, beyond visual line of sight operations, the development of our social license, and electronic conspicuity. Not all of these work products are out yet, but they are all either published or very shortly to be published. We're playing, as you can see, we're also using the work that we're developing in terms of our own publications and channeling that into international decision-making context. So we also hold the chair of EuroCai working groups on SC-VTOL standards, and so that gives an illustration of how we stream all of our policy work straight into the international environment. What we've got on the screen is a particular example of the types of work products that we're producing, and one that I think will be hopefully particularly useful for the consortia that you're looking to form. And this is our project guidance for consortia. This is focused and drawn from the live experience that we've had working over the last year in partnership with different consortia who are in our existing sandbox. And so what we've tried to do is distill the lessons that we've learned from that into a single, easy to use document, and that gives five key points that we think all consortia should be looking at. Now, those types of information and tools are all available on our website, and we will be making, as we develop new tools going through the future flight process over the next 4 years, we'll make those available to you in real time. So what the key issue is, I think for everyone, is what is a regulatory sandbox? It's an environment in which we, as the CAA, partner with innovators to explore through an iterative test process the regulatory challenges and solutions that could be unlocked getting you towards the approval of your specific application. What we've done is recognize that aviation regulation is inherently pro-innovation. From the outset, the sector has had rules around experimentation, experimental aircraft, experimental regulations, whereby the regulator is allowed to provide a degree of latitude to innovators in developing new technologies and business processes, provided risk is as fully understood as possible and mitigated appropriately over the course of that. Now, how do we do that? We do that by getting to know and understand your initiative better than we would have done in the past. That means you receive a dedicated case officer. We work to build a roadmap of regulatory approvals and an evidence base that you would need. We work to support and develop the development of a test plan, which will work through towards a goal that's been agreed with us in advance. There's access to our regulatory toolbox, which I've already shown to you, and access to our community of partners that we've already been working with, and the lessons that we've learned through that process. There are two major qualifications to this. One is that because the Innovation Hub doesn't sit within our regulatory teams, that allows us to work with you much more closely than we would ever have been able to do so in the past. But the quid pro quo for that is that we cannot provide or guarantee regulatory approvals. Any approval has to still be sought through the existing regulatory frameworks. We will clarify them, tell you what the evidence you need to provide is, and work with you to get your application into the best possible state of regulatory readiness. However, approvals are not guaranteed, and there is still the discretion sitting within our teams to apply their view of the risk and necessary mitigations that would have to be put in place for a test to go ahead. We don't also provide live test environments, although we do, as I say, have a network of partners we've worked with across the aviation ecosystem, and we're able to provide some direction as to where you might be able to go with that. And indeed, that's something that the consortia themselves exist to provide. So just important to understand that we don't have live test environments. So our regulatory incubator model is really the model that we think we're going to be applying to future flight, and that we've mapped onto the various phases that we're going to be looking at. So the key issue is going to be is mapping the new requirements that are going to be needed by each of the initiatives, and determining which path each consortia or parts of consortia need to go down at a particular point. And you can see that this is deliberately designed as a loop. It may well be that consortia or parts of consortia go around these loops multiple times as they develop their technology. As Gary said, the outcomes of future flight are not determined, and therefore what we've tried to create with the regulatory incubator is a process that consortia and individual developers can go around multiple times to ventilate and understand the key regulatory gaps and challenges that they need to overcome, test in an iterative way, while always working towards two key objectives. Those are your trial in 2024 and changes to the policy and regulatory frameworks to allow us to better anticipate what the future regulations need to be. So you'll see that there are two different off-ramps from this process, but that ultimately is what we're trying to do and we're working towards with this methodology. So to give you a bit more detail of what those outputs look like, at each of the phases, the new requirements phase and the identifying gaps, the test and explore, the challenge, trial, feedbacks and policy phases, we've mapped out what we see as being each of the outputs that we would expect to share with either the innovators going through the process, with future flight itself, or with our core regulatory teams. And I think this is one of the key outcomes, is that we're not just trying to shape and deliver products through a test cycle, but we're also trying to understand what the regulatory frameworks need to be for the future to enable those technologies which get through this process successfully to ultimately be deployed in future. So we're not, for example, getting into how to certify a particular vehicle itself or anything like that, but thinking about what is the broad regulatory architecture that's going to be needed alongside those trials that ultimately have to be delivered, so that in future we have a regulatory framework that is pro these technologies and is responsive to their particular challenges. So the Future Flight Challenge is designed to align against the various phases. What I've got here is as what we see as the activities that are going to be delivered across those phases. In the setup phase, we're in the process of agreeing exactly how we're going to work with the Future Flight Challenge and recruiting dedicated innovation and regulatory advisors who will be available to the consortia, the Future Flight Consortia, as and when they form. So we will be putting dedicated staffing into this program. At the initiation phase, we need to, and again, this comes into the uncertainty about where these projects are going to end up that Gary's highlighted. What we need to do is understand and assess exactly what the regulatory skills each consortia or development are going to require, whether that's, if we're looking at a vehicle, it could be airworthiness surveyors, it could be flight ops inspectors, it could be air traffic control expertise. We need to bottom all of that out. We'll then use our resources and Future Flight resources to recruit those additional staff, and we will then work with each of the consortia to define the concept of operations for the Farnborough trial at the end of the day, establish a common understanding of the regulations that are going to be involved in that process, map out the regulatory challenges, and then work with each of you with a dedicated case officer to understand what a test plan would look like for that consortia. Alongside that, the work of the regulatory hub, the regulatory incubator, is going to help us understand and collaborate around the development of these test plans, building the evidence bases that we need, both to allow the tests to go ahead, the demonstrations to go ahead, but also to build our future core functions, so that when we look beyond future flight, we have a CAA that's equipped to respond to the future aviation market. And all of that is going to be mapped out and agreed within a technical proposal that's going to underpin all of the CAA's involvement in this process. At present, you can log on to our website, which is caa.co.uk/innovation, and you'll be able to see all of the regulatory tools, our existing sandbox work that's in place, our existing regulatory lab work that's in place, and get updates from us on that. Our ambition is to be stood up with the capability in advance of the consortia signing the agreements with Future Flight. But in the interim, we'll look forward to engaging with the Future Flight consortia through Gary and his team. Thank you.
That's great. Thank you, David. So moving on, we've got Nick Fleming and Katerina Busatil from BSI. So over to you when you are ready. Thank you.
Good morning, everybody. I'm Kate Busatil, and I will be taking the first half of this session, and then my colleague Nick will take the second part of it. So what we want to do is talk to you a little bit about standards and how they fit in generally with industry, and also then moving on to how we can support innovation and how we're already supporting innovation. Okay, so who are we? We're the British Standards Institution. We are the UK's national standards body, and we are appointed by government to be so. We're also the world's first national standards body, established back in 1901, and we're a founding member of ISO and IEC. You'll see the building on the right, that's our base in Chiswick. It's currently empty, as you can all imagine. We're all working from home, same as you are. So I mentioned ISO. So what do we participate in? As a standards body, we produce UK standards, national standards, but we also participate fully both at the European level in CEN and CENELEC, but also at the ISO international level. So we will draft standards, we will propose standards at ISO, we will vote on standards that have been put forward by other countries, and we will have a full UK position on each standard. So I mentioned the standards themselves, and basically we participate in the red part of this pyramid. So at the very bottom of the red part of the pyramid, you'll see we've got the sponsors standards of BSI PASs. These are particularly good for innovation because we can produce them quite quickly. We can get the stakeholders together and get the key findings that people have on best practice for a standard and trying to develop something for industry that they can use at that point in time. And we can do that within about 12 months. Going up from that, there's the national standards, the BSs I mentioned just now, the regional, the European ones, and the ISO. So you can see on the right, the arrows show that the BSI PASs and also the UK national standards, they can easily become international standards at a later stage. So they don't just stay at one level necessarily. So who makes the standards themselves? Well, we work with between 12,000 and 15,000 committee members, and they cut across trade associations, certification bodies, government departments, universities, professional institutions. Our key aim is to try and get each committee as well balanced as it possibly can, so that we can get the voices of everybody represented in that industry and develop the standard accordingly. So the standards themselves, just to make it clear, we're not regulation. So standards are voluntary and they are market-led. They're an agreed way of doing something. They're best practice. They're putting together all the expertise from industry into a standard that helps the industry go forward. They're also made legitimate through consensus, and they go out for public consultation. So every standard has a public consultation phase, and we consider all the comments that come through. Once they're published, they're then revised on a regular basis to make sure they're still valid, and they're supported by testing, certification, and accreditation. But they're also used occasionally to demonstrate compliance with regulation, so they fill in that gap quite nicely beside regulation. So where do they come in terms of innovation? Well, actually, it's really good to get in at an early stage with standards, because we can pull together all the relevant parties who are all working slightly differently, and there is a slight confusion in the market as to the best way forward. So by bringing everyone together, we can produce a good practice on whatever it is and promote really good public acceptance, and also promote safety around the standard once we have something in place. So by pulling together all of the information from all the different experts, we can then produce one document that people will work to. It really de-risks the new technologies and helps create that sort of early mover advantage in shared thinking. Obviously, it has to be the right standard at the right time. So the key for us is bringing the stakeholders together. Once we've got that community built up, then we can then start to develop the standard and test it and launch it. But come in too early and it'll still be far too quick to make decisions about the best way forward in terms of a process, or come in too late and you've already missed the boat in terms of people who would have wanted this guidance a year or two before that. It's too late, they've already sorted their problem out already. So now I just want to move on a little bit into the aerospace side of things. So we have a huge number of aerospace standards. I did a search yesterday on our website and I found over 3,000 that just mention aerospace in the title or scope. If you want to have a look at what we've got in development at the moment, what the committees are working on, go to this website that you've got up on the screen, standardsdevelopment.bsigroup.com. It'll give you what's in development, what's published, what's drafting, what's at a proposal stage. You can really have a good route around and see what's there. But also we're looking to the future. So as you can see, I did a search for drones, I did a search for unmanned aircraft, and there are proposals going through at the moment. There are 14 ISO proposals that have got drone in them, 52 standards at different stages with unmanned aircraft. So we are currently supporting innovation, supporting aerospace going forwards. Now, I said I didn't want to show all of the standards for aerospace, but we do have this nice little holistic diagram which shows how we look at the aerospace standards. We try and look at it from the whole point of view of what's needed. So just to pick out a few examples here, we've got a standard for qualification of personnel who test. There's a standard around the wastewater coming out of aeroplanes. There's a standard around the cosmetic variations in cabins. So there's all sorts of different standards going from, as I say, from qualification of personnel through to the manufacture of the tires or the bolts that are used on the aircraft. So that's a little bit about what we currently have and what's ongoing. But what about the pockets of innovation that are coming through and how we're supporting that? So one thing I wanted to point out was our lightweighting report that came out last year. Now this is mainly focused on composites, so it doesn't include things like aluminium. It's free to download. This was supported by BASE, and we did a little bit of research around how fit for purpose standards are for composites use in transport. And actually for aerospace, current standards are fairly well aligned, but the future move to new materials means that changes will be needed. And specifically, some of them were around composite manufacturing and technology, the processes, something around welding and bonding of composite structures, for example. Battery enclosures came up again and again, and also things around test standards. So that's just some of the highlights. Do feel free to go and have a look at that report. It's free, as I said, online to download. Another way we're supporting innovation, we're currently working very closely with Innovate UK on the Faraday Battery Challenge. Now, the work that we've got at the moment is mainly focused on automotive, but that doesn't mean that it precludes us looking at aerospace afterwards. What we're currently working on is a whole program, which includes research into the current standards landscape on battery manufacture, development of PASs around battery manufacture. So these are going to be focused mostly on battery manufacture and safety, but we're also pulling together a strategic roadmap for what needs to be done in the future, and that could include aerospace. So if there is anything or any gaps or in standards that you feel you want to tell us about, please get in contact with us. We'd be really interested to hear from you, because that will all go into the strategic roadmap that we've got going on at the moment. And at this point, I would like to hand over to my colleague Nick, who will talk to you a little bit about the work we've got going on drones and also on CAV. Nick, over to you.
Thank you, Katerina. Okay, fantastic. So Kate has talked about some of BSI's work and how standards can support innovation and this regulatory architecture, and also given a bit of a flavour for some of our work supporting electrification, sustainable transport. So I want to spend a few minutes now just walking you through some of our work programs in relation to the deployment of drones, unmanned aircraft systems, and land automated vehicles. And I think the purpose of that really is to, firstly, to stimulate some ideas about how our work could support you and your submission, your bids potentially, to highlight some of the relevant standards that actually you may not be aware of and want to use. And then also, you know, given future of flight is looking at some new classes of electric and autonomous air vehicle, I think speak to some of those potentially transferable issues and challenges. And I think that's quite important because across you know, road vehicles, air vehicles, marine, certain things are coming up frequently: safety of autonomous systems, electrification, challenges around infrastructure to an extent, and generally public acceptance and what that looks like. So if we look at the current landscape for drones and UAS, which you can see there, it's a rapidly emerging space, and mainly these are European and international standards that BSI is feeding into via our National Technical Committee. ACE20, I think, is the main committee that is looking and feeding UK input into that work on UAS standards. The key down the right hand side where it says DPC, that means that standard is currently at draft, or one of those standards is currently at draft, and you can comment on it. Where it says P, it's at proposal stage. So the initial focus, as you can see from glancing over those standards, is very much around safe operation, safe operational procedures, quality, the kind of heartlands you might associate with standards essentially. However, we are beginning to see that extend out into some newer areas, UTMC, UTM, and also work around fuel cells is starting to come through. So there's some interesting projects. BSI has actually recently commissioned some research to take stock of the landscape, the current landscape, to help identify where there's common work going on across global standards in relation to UAS and drones. Also, where that, you know, critically, where there are gaps in that landscape, and of those gaps, what are the priorities for the UK, and where are the areas we might want to take a leadership role. So the research itself is looking across different types of standards, aviation standards, sector-specific type standards that may be applicable for certain use cases, industrial use of drones, etc. But also these, what we might consider to be enabling standards that cut across horizontal areas like health and safety, security, comms, training of operators, and you know, are essentially about sharing the good practice that Katerina alluded to earlier. And in the case of UAS and drones, these may represent some of the gaps that need attention, either to support, you know, safe deployment of the technology in the UK, or from an international context to help the market develop. So, as I mentioned, some of your own submissions projects may help us to identify where those gaps are, but also critically what the approach to standards should be in order to address them in the right way. And there's some interesting parallels thinking about the regulatory landscape and how the landscape for standards is emerging between UAS and drones, and also what's happening in relation to connected and automated road vehicles. So very, very briefly on that, I just wanted to talk very quickly about the role that BSI is playing in support of the safe deployment of CAVs, both independently as vehicles, but also as part of mobility systems. And we're involved in a 2-year project supported by government to help accelerate the safe deployment of that technology. The UK has an ambitious approach in place already, and a policy framework there that's designed to support innovation, and that creates a really good vacuum, if you like, for standards. So as the regulation is still emerging, there's an opportunity for BSI and the UK ecosystem to work together to put in place some of that good practice. And I think what's vital to that has really been the ability for BSI to tap into the 70+ national trials that have been taking place around autonomous driving. And so the standards and good practices we're creating are based on some of the emerging evidence, and that's really world leading. So if we look at the program in a little more detail, you know, as I mentioned, we're working closely with CCAV, so that's the Centre for Connected and Autonomous Vehicles, DFT, Innovate UK and Zenzik to deliver this program. And its core aims are really around how do we accelerate the development of this technology in the UK? How do we support the UK as a global centre of excellence? So somewhere that internationally people want to come and test and design these vehicles. And critically, back to Kate's earlier point around informing international standards, what can we create in the UK as thought leadership and as good practice that we can internationalise through the international standards mechanism? I'll try and rush through these last few slides now because I appreciate we're running a bit late. So when we spoke to the market about the gaps and some of the key barriers facing real world deployment of the technology, some of the things that came up would not surprise you. Public acceptance is a big barrier, and that can relate to lots of different things. Safety, but also the benefits of the technology. Do people want to use it? Do people see the obvious benefits and a change in their own use of their own private vehicles? But also technical barriers around the infrastructure, how these vehicles will integrate with other traffic, and then concerns obviously around issues like data and cybersecurity, etc. So we came out of the research with some clear indications of the types of issues that standards could address. And these cut across a number of different thematics. I haven't included all of them here, but the key ones being safety and how you test data, issues around data, cybersecurity, and CAV from an infrastructure perspective. So critically there, what's the communications layer that's needed to support these vehicles deployment at scale? What does the minimum viable infrastructure look like to support CAV deployment at scale? Ultimately, in terms of the safety and testing aspects, and if you're looking through to thinking about, okay, how do you know when a autonomous driving system is safe? When we were going through those discussions about how you actually undertake that process, that journey, we kept coming back to some core foundational elements, I suppose, which was, what is the language we're all using? Is it consistent? And that extended not only to the vocabulary that the industry uses, but also when it describes the environment the vehicle operates in. And so one of the first PASs that we're developing is looking at that taxonomy for the operational design domain. And so by operational design domain, that covers essentially a broad remit, but that is how you describe the world, the environment that the vehicle is designed to run in. So what is the ODD is essentially the environment the vehicle can operate in safely. So this became very important because if you just take some of the elements there on the screen, fixed road structures, well, not every vehicle can necessarily run on the same road surface. If you talk about weather, sensors may perform differently in different types of weather. So understanding the ODD of a vehicle has become key. And what we quickly established was there was no consistent, reliable method of describing it. So for organisations like road operators or local authorities that were keen to allow trials to take place on their roads, they found it very challenging that people weren't describing their vehicle's capabilities in a consistent way. So I'll just wrap up now. So the program, the CAV program, we've got 4 PASs in development, as well as this centralised vocabulary. And those PASs are really focused on supporting, initially at least, supporting trials and advanced trials, as well as development testing. So we're hoping that we will see a roadmap through to standards, ultimately supporting deployment. The PASs, I've mentioned the ODD work. There's also work looking at a standardised safety case. So when you're actually running your trial, doing your R&D testing, what is the safety case for that trial? And that ultimately might end up as a safety case for the vehicle in the future. Also, issues like what data must be collected in the event of an accident to support the proper forensic investigation. That's another interesting area for us. So I just wanted to wrap up then by firstly sharing our contact details, because we've touched upon a number of different issues today. So if you're interested in anything Katerina or I have touched upon around specific work programs, Faraday, battery development, CAV, or the lightweighting work, please get in touch. We're also interested to hear from you generally if you think your submission or your project might address standards in some way, then we'd love to hear from you. We've recently had Dan Barlow join BSI from Rolls-Royce and via DIT. So Dan is someone who's now heading up BSI's innovation policy team, and will be working very closely with Katerina and I in relation to the work we do around future of flight and aerospace. So also I encourage you to reach out to Dan if that's someone you know from his former life. The ISO work that we talked about and BSI's committee work, again, if that's something that's of interest to you, finding out more about those international standards that the UK is feeding into, Sam Lee Wooten there is the best contact. And then the drones research that I mentioned, please get in touch if you feel you have an interest in contributing to that. We'd love to hear from you. And so Julie Weller is the best contact there. So just to wrap up then, standards, I think, we feel are going to play an important role alongside or as an alternative in some cases to the regulation emerging here, that regulatory architecture. So, we'd like to hear from you if you think any of the standards that we've mentioned today could be relevant to your bid, your work, your submission around future of flight. But also, I think crucially from BSI's perspective, we're very keen that the standards that do emerge in this area are based on the work that you're doing and are based on scientific foundations and real evidence. So we're keen to engage when these projects start to deliver some of their early findings to help us inform where we go next. So apologies, Michelle, for overrunning.
Thank you. In the interest of time, we'll move straight on to Chris Reed, who's Professor of Electronic Commerce Law at Queen Mary University of London. Over to you, Chris, and then we'll head into a break.
Right, well, thank you very much, Michelle, and good morning, everybody. I was asked to come along and talk about law and regulation. And the problem is that there's just so much of it that in 15 minutes, I could barely scratch the surface. And so what I thought I would do, if I can, get the next slide, is change the perspective and say, let's look at it from the perspective of the consortia who are trying to build these technologies. What do you guys need to know about law and regulation? And it seems to me that there are 2 basic questions. And the first one is one that everybody was shouting about at the Birmingham workshop. What is the law and regulation that we need to integrate our technologies with? And it was obviously unsatisfactory that nobody could give you an answer. And the reason for that is quite simple, that the existing law and regulation that we have will need to change. It's just not appropriate for autonomous vehicles. in aviation, it assumes manned flight, it assumes pilots, it assumes all the existing infrastructure. It will clearly need to change. And so one of the things the project will have to do is to work out what the future direction of change is. It may not come up with complete answers about what the legal and regulatory framework should look like, but at least we have to know the direction in which it's moving. So that your first question is, where is the law and regulation going? That's the thing you need to know so you can integrate your technology with that. And then the second question, which is quite specific to the technology you're making, is how do we need to shape our technology to comply with this emerging legal and regulatory landscape? And that won't just be a matter of box ticking, because this is a moving target. This will very much require judgment about how close you can get to compliance, and then through things like discussions with the CAA and others about how far your technology is going to be appropriate for use, even if maybe some of the boxes don't seem to be ticked quite well. And an important part about all this is that the needs of developing technology also need to shape the new law and regulation. I've been working in the field of law and new technology for about 40 years now, and pretty much every time we've tried to produce new law and regulation without knowledge of what the technology can actually do, it turns out to be wrong. And we have to redo it some years later after a period of confusion. So it's really important for there to be feedback from the people who are developing the technology to those who are trying to explain how the law and regulation should develop, and vice versa. So there needs to be a constant dialogue. And that's exactly the kind of thing that David Tate was talking about when he talked about the regulatory sandbox. That's an example of the kind of feedback which is obviously needed. So what's the basic legal and regulatory framework you will need to understand when working in consortia? Well, obviously there is aviation-specific regulation, a lot of which David Tate's already talked about. So things like standards and certification. Can your drone or your other autonomous aviation vehicle actually fly? Can it be certified to fly? What are the operational regulations? How do you actually have to operate it in order to be safe, and so on? And how do you integrate it with other air traffic, particularly in the light of things like the Flexible Skies program, the idea that controlled commercial air traffic is no longer living in Class A airspace, but is now moving out into Class G and mixing it with the rest of us. So I don't want to talk much about that today. I've got one slide very briefly, just picking up a few issues there. The most interesting part, I think, is the second part, which is liability and insurance. Because if you don't understand how liability for something going wrong and loss being caused by your technology is going to be allocated between the various actors, it's actually very hard to build in the protections that you need and to structure your business in a way that will enable you to cover off those risks. And of course, insurance is an obvious way of covering off liability risks. And one of the vital questions everybody will have to know is, will the insurance market cover these liabilities? Because if it won't, if you can't get insurance, then you're just not going to be able to fly. It's as simple as that. And then there is a huge, broad field of other law and regulation. So health and safety has already been mentioned. That's not on my slide, but I could have made 20 slides on other potential law and regulation. I just picked out two things which you might not have thought about. One is planning and environmental law, which is quite locality specific, but will be about things like, can you get planning permission to actually operate your technology in this particular area? Are there environmental concerns that you need to deal with? These are going to be important issues. And I also throw in data protection, because there will be a huge amount of information relating to individuals which will be captured by the kinds of new technologies we're talking about. Something as simple as that person X flew from A to B. That is personal data. You are now worrying about data protection laws in the way that people who develop technology may not have been. And if you don't build in compliance systems right from the beginning, you may find it very difficult indeed to achieve compliance and be facing regulatory liabilities. So what about aviation-specific law and regulation then? Well, that's primarily a CAA activity, but clearly it needs input from as many useful people as possible. So that can include external experts on aviation law and regulation, and more importantly, as I said, feedback from the consortia on the technologies they're developing, so that the CAA can work out what things its regulation will need to cover, and also will work out how to produce regulation that people are actually able to comply with. It's been not uncommon for regulators working in the dark to produce regulation that is just either meaningless or is impossible to comply with. Sadly, I've written long articles about that. Standards and certification is obvious. That's probably something that you're all aware of if you've been working in the aviation space. And that's not just for aircraft, that's also for the infrastructure in the very broadest sense, all the way down to hydrogen cells and safe batteries, and up to the airfields that you're using and the other communications infrastructures that you're using. There's operational regulation. The big challenge for all of this is going to be integration with other air traffic. If we can fly these autonomous vehicles in their own little sanitized corridors, then of course that problem goes away. But I don't think that's going to be possible looking at the long-term future here. So that's a particular problem. And that also leads to the problem of interoperating with foreign aircraft, which are coming out of a system which isn't the same. So we have the difficulty of interoperation all across the aviation ecosystem. Very complex questions that the CAA will have to try to deal with, and will need lots of feedback and assistance and understanding in order to do so. Let me move on to the liability question, which I think is a particularly interesting one, because it's quite clear that existing schemes of liability aren't appropriate for autonomous vehicles of any kind. In aviation, we already have something that's easy to understand. We have strict no-fault liability to people on the ground who suffer loss or injury because of the operation of an aircraft in flight. That's under Section 76 of the Civil Aviation Act. And that obviously works. That's something that all of those of us who fly cover off by insurance. That's quite simple. But behind that, there's a whole load of law which is much less clear and much more difficult to deal with. Primarily, if we're looking at claims for, let's say, aircraft collisions, or we're looking at a liability based on an aircraft which is now being allocated between the people who operate it, the people who produced it, the people who designed it, the people who were flying it. These are primarily based on the tort of negligence. And there is a real mismatch here between the law and what we're trying to do in this project, because the tort of negligence is based on human foresight of risk and the measures that humans take. And in the context of aviation, that primarily goes to the pilot. So we're talking now about the decisions the pilot made. What should the pilot have foreseen as a risk? How should the pilot have taken measures to deal with that risk? And we have a reasonable understanding of how humans think, or at least we believe we have a reasonable understanding of how humans think. And we have a body of law that's been developed over well over 100 years that helps us to understand how to allocate liability between the various actors. That all falls apart once we have autonomous decision making, because we really can't apply the same standards and even ask the same questions about autonomous decision making technologies. So if we keep the existing legal framework, we're going to be moving that legal assessment back to preceding human decision making on things like design, training, testing, and revision. So if we have an autonomous air vehicle that makes a bad decision, flies into the wrong part of airspace and has a collision with an airliner, then we'll be asking questions like, when it was being designed, should this have been foreseen by the designers? When it was being trained to develop its autonomous capabilities, was that training adequate to deal with this risk? Testing, exactly the same question. And then revision, once we find a problem, did we revise it to deal with that? And then was the design correct? Was the training correct? Was the testing correct? What this means is responsibility as between the players is going to be very hard to identify and allocate, and it's actually going to be very expensive to litigate. So one of the questions we're going to have to decide is, do we need an aviation-specific liability regime? And we don't know the answer to that, but it's one that's certainly worth thinking about. The way we've gone in the UK for autonomous vehicles on the road is to say there is strict liability to people who are injured by autonomous vehicles, and then how that liability is allocated between everybody else is left to the existing law. I'm quite confident the existing law will be able to cope, but it might take it 20 years to be able to cope. And I'm not sure that we want to wait 20 years of uncertainty before we know how to allocate liability. What about the insurance sector? Well, we need insurance if we're going to fly, and the insurance sector has a real reluctance to cover risks that it doesn't understand. So we have to be able to quantify the risks to an adequate level. At the moment, if you ask the insurance sector, do you understand the risks of autonomous flight? They go, no, we really have no idea what the risks are. And what that means is that if they're going to cover it at all, they're going to cover it at such a high premium that it becomes completely economically unviable. So clearly, we need a dialogue between technology producers and the insurance sector in order to satisfy them that the risks are understandable enough to provide insurance cover. And it's rather more sensible to do this as the technology is developing, rather than waiting till it's being developed and then starting to talk to the insurance sector. And so here at Queen Mary, we're lucky we have very strong links with Lloyd's of London and other insurers, because we have a major insurance law program, and we're quite well placed to link up those things. And certainly we also need to understand the needs of the insurance sector, because they live in a heavily regulated environment. They have all sorts of obligations about their capital provision, about the kind of risks they cover, about how they go about assessing claims, and the regulation and the liability regime will need to be designed so that it fits in with the insurance sector's practices and needs, and thus enables them to cover off their insurance. And so I guess to finish off, because I've deliberately tried to keep this nice and brief, right, what do I think that consortia need in terms of coping with law and regulation, in answering those two questions I posed on the first slide? Yeah. What is the law and regulation, or which way is it going, more accurately, and what do we need to do to make our technology compliant with it? So what do they need? Well, number one, they need to understand the legal and regulatory regime that applies to their technologies. And it's not enough just to tell them what that is at the moment. They really need to know the direction in which it's developing and how it's likely to end up. And they also will need to understand how they should allocate liability between consortium members. That's going to be really very important in terms of both consortium agreements and insurance, who takes out insurance and how much are they covered for. They're going to need help in achieving compliance, because law and regulation is written primarily for lawyers and for judges and people like that. Very little of it is obvious to a person who reads it. I've spent quite a lot of time doing research projects with technologists who tend completely to misunderstand the law that they're reading because they don't understand the broader context in which it's working. Consortia will need to provide feedback for developing law and regulation, and they might therefore need help in framing that feedback in a way which is going to help lawmakers and regulators to produce the right answers. And they're going to want to talk with the insurance sector so that they can make sure that the insurance sector is happy with what they're doing, understands the risks, and that they can discover any problems in getting insurance which can be fed back into the process of developing law and regulation. So that's as brief an overview as I think I could possibly give. And I'd hope to leave 2 minutes for questions, but I think we've already overrun, so probably not. Michelle.
Thank you, Chris. I appreciate you keeping to time. That's brilliant. Yes, so we'll have a Q&A session at 11:55. Right now, we'll let you go for a bit of a break, and if we can all be back at 11:45, that'd be great. And if you'd just like to join me in giving a virtual clap and thanks to all our speakers this morning. So we'll see you at 11:45. Thank you. everybody. We're going to start off with Gareth Watmore from Drone Prep. I'm going to go into Q&A session, so please put your questions into the chat function for our speakers. And then we've got a series of pitch presentations after that, and then we'll end the session to enable you to go off for your pre-scheduled meetings that you have. So Gareth, over to you when you're ready.
Lovely, thank you, Michelle. Just want to check everyone can hear me okay?
Yes, we can.
Perfect. Okay, yes, so I'm Gareth Watmore. I'm the founder of Drone Prep, and I'm here today to talk about the importance of landowner and ground-based stakeholder engagement in achieving our future ambitions for future flight. But before jumping into all that, I wanted to reflect really on the last sort of 2 to 3 weeks. Obviously, I put some checkered flags there at the start of the presentation. This is actually the last feature presentation of the phase 2 future flight workshops put on by KTN and Gary and the team. And I'd like to thank them all because I think they've been absolutely superb. Saved a lot of mileage along the way. I mean, it would have been Liverpool today and Cardiff and Cambridge, I believe. So as a startup, you know, that's also particularly welcome. Looking back actually on the 16th and the 23rd, the other sessions, we had some really inspiring visions of the future outlined by Daryl Swanson and Nick Anand of the Avery project. We learnt a bit about Snowdonia Aerospace and Connected Places Catapult, introduction to Cranfield University, and you know what struck me is that from the 2-minute pitches at least is we've got some amazing SMEs, universities, all wanting to accelerate and put their mark on this industry. So it's been really fabulous to tune into all of that and see, you know, who's doing what and what's possible. So just wanted to start there really. So moving on to the next slide. There we go. Okay, so I think this is where we're all trying to get to, isn't it? This is the promised land. It's a grand vision where the capabilities of the aviation and transport sector to serve the UK economy, society, and improve the environment, evolve and adapt to solve 21st century problems. In terms of freight and people, and movement of people even, the technological opportunity is absolutely huge. I think drones and eVTOLs will allow a more flexible, more dynamic and more efficient transfer of goods and people. We've already got drone integrations with construction, energy, communication, maritime, ground transport sectors, and we'll continue to do that through future flight as well. There'll be a catalyst for growth in these areas and help actually in normalising the presence of drones and improving the public's perception of drones for the future as well. So for me, there are big wins here in the third revolution of flight, as Gary likes to call it. There's a huge potential to decarbonise transport, reduce ground-based traffic congestion, and indeed our reliance within transport planning of designing places. You know, at the moment, we're all places are designed around the car, and I think, you know, some of the technologies that we've got here, we move away from rigid transport like roads and railways, and that's quite exciting for the United Kingdom going forward because, you know, we can unpack regional inequalities and serve places in ways that we've just not before. What struck me from all these sessions, you know, we've got so much amazing talent out there in our industry, and a lot of it comes from aviation, and that might sound like a silly thing to say. You know, obviously future flight is aviation related, but you know, in the context of drone prep, you know, what I'm getting at here is the people within the groups tend to specialize in aviation. So that's specializing in high altitude airspace. So from a drone perspective, that's general aviation airspace. That's airspace above 120 meters altitude. A lot of the people in here are also specializing in fixed movements between fixed infrastructure, so runways, where contact with landowners and the public is at a minimum. If we have people in here that already specialize in ground transport, we're talking about the small ribbons of land that we've got out there, the roads and the railways. We're not talking about the vast reams of land that we have out there in the United Kingdom that aren't roads and aren't cities. And actually, if you know, we think we live on a crowded island, but in many respects we do not. If I was to pick anyone up in this room now and place them automatically anywhere within the United Kingdom, there's a 7 in 10 chance they'll be in a farmer's field, perhaps next to a cow. And we often don't think along those lines because we see what we perceive, and most of us live in built-up areas and engage with transport, which essentially means that we see the things around us and not the things that we don't see. So I'm here really to sort of introduce the concept that the future may not indeed look like that. It may not look like it's sorry, I lost my flow a little bit there. Let me just I've just had my notes disappear on the screen on top. I won't be a second. Yeah, so essentially the future doesn't look like what it's going to look like previously. You know, we're not going to be flying from fixed places anymore. We're going to be flying dynamically between lots of different areas of land. And it's all about realizing that possibility. So maybe if I try and explain it, is to win, we all need to understand and consider the public perception of land-based stakeholders. And the public. We need to consider the regulations linked to land and low-level airspace of where ground-based stakeholders and the public have an interest or a right to bring them with us in the projects that we seek to achieve. So by now you can probably tell my background is transport planner. So I've worked on many planning applications, road schemes. My role has been to convince local authorities that the transport impacts of a scheme would work and would be accepted. And I've worked with multiple landowners and stakeholders in a regulation-rich environment. Previously, before doing drone prep, I was involved in London 2012. I was on the planning application for the Emirates Airline cable car, work at Tag Farnborough, work with smart motorways, new hospitals, shopping centres, distribution centres. And when I got quite good at that, I went solo, and I decided then to concentrate on things I was more interested in, and that sort of went round sort of public perception issues to do with cycling and trying to get more people to cycling. And we invented an app called Cyclodio, which was a sort of video linked to geo-located routes on the ground, and we had a project to map the Scottish Canals network. And at that point, I got really excited. It's about 2014. I got really excited by the drone consumer technology that has sort of come out quite recently. And we decided on this Scottish Canals project that we were going to map the Scottish Canal network with a drone. So I got my PFCO, and immediately I was so frustrated. I couldn't hardly do any work at all with it. Actually, my flight paths were quite restricted, and you couldn't do a lot within an uncongested area. So in short, there was a lot of things to consider as a new drone pilot trying to do different things for the first time. And Chris touched on some of this stuff quite eloquently beforehand. I mean, there's a lot of interactions with land ownership and a lot of interaction with land-based laws. So I say Chris did touch on some of this stuff before, but from our engagement, you know, the land ownership is actually key. I mean, we all know that landowners do not own the airspace above their land, but in many cases they do have rights to it. And you know, this is based on trespass and nuisance issues, which is why, you know, if you have a crane on a work site and you're oversailing at an altitude of anything up to 120 meters, you need to have a permit for that crane to be in that airspace above land, because it has an effect on the people on the ground. And this is the key, I think, behind, you know, most of the stuff with future flight, is we are looking at use cases now which are going to interact with the land in a way that's never really been done with aviation before, and it's unlocking all these amazing use cases. But we need to get that relationship with the landowners correct. So, for example, you know, many local authorities, they have bylaws. You know, it's the council's role to protect the public. We're working quite closely with Bristol at the moment to open up some airspace there for low-level drone flights. And it can be done with the right policy and with the right insurances. You can sort of change that whole scenario and open up lots of opportunity, but it's all about getting in there and listening to the landowner and listening why they've got these land-based regulations in place, and then unpacking that all and seeing how that fits around what we're trying to achieve as future flight consortias. Interestingly enough, as I mentioned before, farms are 70% of the land in the UK, and if you talk to a farmer, again, it's regulation, but it's also public perception issue here. Most farmers are scared to death of eVTOLs. They might not even know what eVTOL is. They're scared to death, certainly, of drones. Their main issue with the drone is they think that the drone is coming over their land to steal some really expensive bit of kit that they've bought, which really props up their farming industry. So it's all about engaging with them and explaining to them why the drones are there, how they can be reported, and how they can have a mutual benefit going on. So, I mean, the frustration I had with my PFCO and with my sort of small transport planning consultancy is, as I mentioned before, I couldn't really do much work with them. But I soon found out that actually, if I was to aggregate some data that I use quite regularly within town and country planning circles, which was land-based data, I could actually open up some really interesting flight paths. So, I mean, this was probably about 3 years ago, and I aggregated some data into a basic Google Earth engine type of application, all the land parcels for the United Kingdom, and essentially, if I had a quick way to find out who owned that land and engage with them and explain why we were doing a flight, I found out that it was quite possible to, providing we had the right protocols in place alongside the PFCO, we could fly longer sorties and deliver work which had a greater commercial value. And I thought everyone was doing this, and this certainly wasn't the case. And so now we're involved. We've had the backing of Her Majesty's Land Registry and Ordnance Survey, and we've been building a platform to share with others. And to give an example of what that could mean, so the small little use case there of the drone flying over the 7 estuaries, and perhaps dynamic or interesting, but this is where it could go if we get this relationship right. This is Reykjavik in Iceland, and the way, so they've become the first place in Europe which now have active drone deliveries in Europe, and it's a fantastic achievement. And the way they've done that is obviously they've had to prove the safety case, and one of the key areas that they've worked in there is they've got the Highways Agency for Reykjavik on board. So they've proved the safety case. They've got parachutes on these drones made in Israel, but crucially they've engaged with the landowner being the Highways Agency, and they can now overfly these routes in Reykjavik and be a functional delivery service. And there's no real reason why we can't look at that type of thing in the United Kingdom. If everyone works in their respective areas, we can also look at those relationships, the existing ribbons of land, and try and present the evidence that it's safe to do so with everyone's help. But the engagement with the landowner and overcoming their regulations is absolutely key to achieving that. So, as I mentioned, we're building a platform with the help of Ordnance Survey and HM Land Registry. We've identified, our different markets, I suppose. We've got 170,000 recreational drone pilots, and none of them really know where they can fly their drone legally. They all sit on forums, actually, on the internet and bemoan this a fair deal. We've got 10,000 enterprise drone companies, the likes of people that might be tuning in with this call, and they're all wanting to know how to access low-level airspace to deliver new drone use cases within the economy. And on a wider note, I suppose we also have eVTOL companies wondering how dynamic their systems of flight can be. Can they do flying to rural areas? Can they extend from UAM to something else? And on the other side, we've got this large strategic group of landowners that own 80% of the land in the UK. They do have rights over the low-level airspace above their land, but they don't know how to communicate that drone policy. And actually, once you get in there and explain to them what the possibilities are and how we can de-risk certain things and how drones aren't necessarily the worst thing in the world, then we found through our engagement, and we've been doing it for a year now, that we have a number of different types of landowners that really want to get on board with this and help define what this future landscape could look like. So again, the basic premise is, a drone user needs a landowner permission to take off and land, and sometimes to overfly property at low altitude. But they do find it difficult to access who owns land, and how to agree those terms of access. And the landowners, again, to summarise, they are concerned about drones flying from and over their land without their permission, but they don't know how to publicise that. And this all boils down into public perception issues at the end of the day. When you have drones flying somewhere where they've not been notified, or they've not spoken or engaged with the stakeholders on the ground, it creates bad practices. Fear and mistrust, misunderstanding between each group results in negative perception, something we all want to tackle and get right. It undermines the development of all of what we do in the industry. On a side note, we found out on Friday, a team that I'm already working with via stage 1 of this Future Flight Challenge and Future Mobility Zones, that we now have permission to fly drones over to the Isle of Wight, and we're working on extending that capability. That's brilliant for public perception. That's exactly where we should be starting. Medical use cases, whenever we go out to landowner clients and we talk to them directly, they are keen to see innovation. They're definitely keen to sort of hang their coattail on this, drones for good use case. If we can do the things that are good for society and good for the environment, then we'll have a really good way of getting in there to influence landowners and people that make rules up about landowner interaction. So the platform we've got, we're able to search for any location in the UK. They can directly inquire with the landowner about the conditions of flight, within the area that they have rights to. You find already as a PFCO pilot that a lot of the large strategic landowners already have a policy, national trust, etc. It's not particularly well communicated, but they have already consulted their legal boffins and legal associates, and land is the richest sector of them all. So when they put up the barrier, there's usually a good legal reason why that's the case. We also allow landowners to share their policy on drone access. We want to know from landowners whether they're willing to accept flight paths from eVTOLs and drones. At the moment, some might want a complete ban, and we do have to respect their privacy on that, but we can also work and lobby them to show all the good things we're doing. And this is why things like Future Flight and these drones for good medical use cases are brilliant for doing that. We can sort of win them over in the longer term through our public perception work. So, we want to inform the drone industry and recreational pilots where they can and can't fly at the moment in low-level airspace, and help build that relationship between landowners and the drone community together to open up more possibilities for everyone. We're in beta. We're about to launch next month. The landing page won't look like that at the moment, but it soon will though, and we'll have some functionality on it. So please do jump in, have a little look. Also consider whether you would want this type of knowledge and this type of engagement as part of consortia that you're building for future flights. We'd love to be involved. We love to collaborate. That underpins everything we do. Everyone in our team is either a drone pilot, a PFCO holder, or has really rich and interesting knowledge with land and landowners, and good relationships with those. So yeah, we'd love to be involved with any of you, and we'd love to share in some of the work that we're already doing. Thank you.
Thank you, Gareth. So some interesting presentations that we've had today. If you've got any questions, please pose them to them. We've got quite a few coming in for this Q&A session. If we can't get through all of them, we will send it in a transcript to you so that you have a copy of those. So, right, I'm just going to go through the questions and just to ask you if it's targeted to a specific speaker, can you indicate that? But if they're general, I'll put it to the whole of the panel. So the first question, David, I think this is about turnaround in the FFC. So if you're going to be supporting the regulatory aspects in future flight. Is that reasonable?
Hi, thanks. Yeah, the regulatory application process will apply as usual. However, the hope is that given the what will be quite intensive upstream support from the CAA's innovation team, that will ensure that we're sort of improving the regulatory readiness of any of the applications that are ultimately going to be submitted to the UAS team, so that we reduce as much as possible any of the ping-ponging backwards and forwards, and remove any of the as much in terms of the pinch areas that might make things challenging to approve.
Okay, thank you, David. One for you, Gary. It's a question about level of engagement with CAA, NATS, ANSP. Should the consortia agreement be signed also with them?
I confess that you'd have to just say that again. The consortium agreement signed with CAA, that's sort of slightly confused me. Or is it with another body?
So obviously for phase 2, they need a consortia agreement, and they're wondering if it should be signed with CAA, NATS, or ANSP.
Right, I understand. So no, I don't expect anything to be signed with CAA. I think CAA are kind of an independent body providing advice, and we work with CAA directly, so not with CAA. For any other body, if it is down to you, if they are a participant, a formal participant in the consortium, and certainly if they're looking for funding and being part of the consortium, they have to be part of the consortium agreement. I will just say on the consortium agreement, we keep pushing. We mentioned this at the workshop, the idea that we want you to think about consortium agreement early, so that when eventually the competition opens, you'll find a reference to consortium agreement. Really, we're just encouraging people to think very early about it there, so we don't get later on at grant time and have people then work out there is complexity in the consortium agreement. So please think early. But no, only people directly looking for funding in the consortium would need to be part of the agreement.
Okay, so while you're there, how does noise fit within public acceptance and non-aerospace regulation research areas?
Yeah, I mean, noise is central. I mean, interestingly, I'm ex-Rolls-Royce, and one of the groups that came in my remit for, gosh, probably about 10 years was the noise group, so I'm kind of well versed in this. And for classic aviation, noise, I would say, causes a bigger reaction, a bigger negative public reaction, and more anger, irritation than carbon emissions. I think that's changing, but that's a reality because it has a direct impact on people. So noise itself will be one of the dominant barriers in this, and particularly because people perceive we're looking at new lower flying vehicles with different noise tones, and therefore it's not just people near airports, potentially more people. So noise is a key enabler. What we would expect is that people have that as one of their, not one of their prime deliverables, but it's in their consciousness. I know some people are looking to do that themselves. Some of the vehicle manufacturers, noise is a key target for them. There are bodies you may choose to partner with. I won't point out any particular ones. It's not my job to do that, but there are some obvious places in the UK that have good noise technology and understanding and can do that research for you. So it is a key enabler in that public perception piece, and we would expect people to recognise that.
Okay, thank you. It says, are we mandated to go through the CAA Innovation Hub process to achieve CAA approvals to fly in FFC?
I think that's one for David, I would guess.
No, absolutely not. However, and linked to one of the other questions that's in the chat is, will the CAA support the Innovation Hub be free? Yes, absolutely. And I would suggest that you're obviously legally entitled to continue to submit an application for an OSC in the regular way. However, given that UKRI and Future Flight is paying for CAA, access to the CAA's innovation team, and our ambition is to improve the regulatory readiness of your proposals before your applications before you submit them, we would hope that you'd want to come and work with us.
Okay, thank you. One for you, Gary. Will we be mandated to perform a trial at Farnborough? It is possible the farmer trials may not align with use cases being developed by consortia?
No, absolutely not mandated. For the avoidance of doubt, that's not a commitment that we will fly at Farnborough. It's a kind of visionary intent. Wouldn't it be a great thing to do that? And the formal end of the financial part of the programme right now is 31st of March 2024. Farnborough, 4 months later, feels like a fantastic flagship opportunity for the UK, for all of us to do something, which is unlikely to be a mandate. We just think it would be a good marketing opportunity for people who are successful.
Okay, thank you, David. Someone's asking if you could say more about international aspects, key if vehicles are to be exported.
Yeah, very happy to that. The learning that the CA is gaining through the work that we're doing with Future Flight is being streamed directly into our regulatory and policy teams. They're going to be taking part, obviously, in the sort of downstream work. As soon as we have got to the stage of the consortia being formed, they're going to be directly involved in developing policy to respond to the needs of those consortia. And that's going to allow us to soak up as much information and insight as possible on these future technologies. We sit as I discussed in my presentation, we're one of the chairs of the EuroCai working group on SC VTOL standards development, and all of the work of Future Flight is going to inform the positions that the CAA develops internally, and therefore that we advocate at an international level. I would also add there's a lot of interest at ICAO in this type of work, and in what the CAA as a group of fairly select regulators who are involved in reviewing these new types of technologies gains from our work in partnership with industry, and that we can then feed back up into the ICAO decision-making processes. And ICAO has some very strong work streams and innovation that it's been developing over the last year that the CAA is actively involved in, and so all of the lessons that we learn through Future Flight are going to be streamed directly into that.
Okay, thank you very much. So I've got one for BSI here. How do you decide what is the right time to bring stakeholders together in discussing new standards for this challenge?
I can probably take this one, Nick. So basically, standards are aimed at industry. So obviously, it has to be looking towards an industrial application. So we start to put in stakeholders when we have sufficient evidence, sufficient knowledge for a conversation to be had around the development of standards. So what are my messages? If there are any areas that we can help with, if you have any ideas about areas for standardization, do start talking to us now. It's a really good time to start.
Yeah, and I'd just echo that really and say that it's all about what is the likelihood we could, and BSI's, the way we develop standards is about building consensus. What is the likelihood that we could form some industry consensus around a particular topic at the moment? And if there's a good chance of that, a good likelihood, that suggests from a readiness perspective that it might be the right time for standards to start coming in. So yeah, I'll just echo what Kate said really. Okay,
so while we've got you there, is the work that BSI is doing on standards complementary or in addition to CAA, ESA and ICAO standards?
Nick, did you want to pick this one up?
Yeah, I think it's a great question, and to some extent, it's the work that BSI is doing at the moment around drones research that I mentioned. That's certainly something where we want to try and reflect the relationship between standards and regulation. But I think it suggests to me there's a broader activity that BSI needs to do to really map the work we're doing against the existing regulatory framework, and that might be something we can give a readout on at a later date. In principle, the standards work should certainly not be conflicting with any regulation or standards that have been adopted by the industry. So we tend not to put anything into the market where possible that's going to cause confusion. So it should be complementary, but answering that question honestly, I think would require us to go away and do a piece of work to really map the standards, the BSI work and the international standards we're involved with over the CAA, EASA regulations.
Okay. One for Chris. How do you suggest to bring the consortia, tech experts and policy and regulators together, for the higher level needs and not on individual project detail stuff?
Right. I think that's going to be a very important question for phase 2. If, as Gary hinted at Birmingham, there's some cross-cutting work on the law and regulation side. That's the obvious way to link these together. If not, I think some mechanism will have to be built to bring people together and connect them. So there'll be different people in different consortia who have some understanding of their legal and regulatory needs, and there'll need to be some way of bringing them together and feeding that in. I mean, the one thing I think we're very fortunate about is having David Tate, who's connected with this, because David understands these issues, and he is a great way into the rest of the CAA, which is, as he said, quite a complicated organization with different people working on different things. And he'll be able to direct us to the right people, which will be terribly helpful when it comes to dealing with specific aviation regulatory stuff. On the longer term, big liability questions, that's actually huge because it affects not just aviation or road vehicles, but it also affects things like medical imaging technology, the whole use of artificial intelligence and autonomous technologies in fridges, and it's the whole of life, basically. So sorting out the liability question for the whole of life is complex. I've been working with the House of Lords Artificial Intelligence Committee on this. Everybody is interested in it. Part of the problem is that, as always, there's no political imperative to solve this because it's not a politically sexy thing. Nobody ever got re-elected by saying, we solve the liability problems for autonomous technologies.
Okay, thank you. So while you're there, Chris, how long until this is ready to use fully?
What, the law and regulation stuff? The aviation regulation, that's down to David's gang. And I think it honestly depends. Let me do some prediction because he won't want to predict, right? But I think I'd say that on the basis of what they learn from this, they will make a decision whether they can produce some more general regulation or not, or whether they're still looking at specific examples as they come up. So there'll be a point where the CAA says, we now understand enough about this to have sufficient airspace regulation as we have for, say, traditional aircraft. So we don't have to go for individual approvals to say, can I even fly my aircraft at all? We have generic understanding of what's needed for aircraft. And then you have specific discussions about particular aspects of it. How fast we get there, I think this project will accelerate it, maybe 4 or 5 years down at the CAA level, I'm guessing. For liability, it would depend if we go for an aviation-specific regime. Same kind of timescale for that. Longer if we wait for the general political impulse to do something about it.
Okay, that's great. Thank you. So we'll just take this one last question before we move on to the pitch presentations, and this one's for David. Can you say a bit more about the Sandbox in terms of how much it costs to join, the application process, timescales to join, and what are the time demands on SME? And again, are there any limits on the numbers of SMEs that can join the Sandbox as well?
Yeah, so thanks. Great question. We, in relation to future flight, so we had the Sandbox is a methodology that we use to engage with innovators. And in relation to future flight, as I set out in my slides, there will be dedicated resource which we are going to be acquiring, recruiting in the next couple of months to support future flight specifically. So that resource will be free to future flight consortia. It will be dedicated solely to the work that they are doing, and it will support using the Sandbox methodology. So there will not be an application process other than participating in UKRI and successfully going through its process to access the Sandbox. So it's streamlined and it's an entirely integrated process into UKRI.
Okay, thank you, David. Okay, thank you, panelists. Okay, we're going to move on to the pitch presentations now. These are all 2 minutes. and I will be timing on my phone. And as per the previous 2 times, when the buzzer goes off on my phone, you need to stop talking and we will move on to the next speaker. So first up, we've got Alan Whiteside, who's from NHS Ireland. So over to you when you're ready, and I'll just bring up my timer, all ready to go.
Thanks, Michelle. NHS Highland have recently completed a Horizon European project called SHINE, which introduced us to sustainable healthcare. Came with 2 key concepts to our pitch. The first is the quadruple helix model for collaborative innovation between businesses, academics, the public sector, and the public. The second is smart specialisation. We used the opportunity of the SHINE project to focus on green healthcare, and it's relevant because one of the areas of focus is transport, and the other areas allowed us to develop clusters with other partners such as Scottish Water and Highland Council and Argyll and Bute Council, which will also have demands for future flight challenges. Can you pass on to the next slide, please? So what we want to look at is cross-sectoral collaboration, particularly given our remote and rural nature. So we need to work with other key sectors and also the public to identify the needs and where technology can deliver this. As I mentioned, we have 2 clusters in existence ourselves, and are members of a third looking at smart water, smart buildings and energy, and transport in the region. What we want to do is to work with other clusters, particularly remote and rural, to look at how we can collaborate on developing markets for future flight challenges. Partnerships crucial to build up these applications to make these viable solutions, and happy to talk with professionals and others with shared interests. Thank you very much.
Okay, thank you. That's great. Next up is Richard Ryan from Blakiston's Chambers.
Yes, hi. My name is Richard Ryan from Blakiston's Chambers. I'm a barrister that practices in drone law and have done for many years. I have a PFCO, so I'm one of a handful of lawyers on the planet that actually flies drones and advises on the law. So I truly do practice what I preach. As a point of disclosure, I also do work for BAE Systems, and I'm happy to be contacted directly in relation to any potential opportunities for collaboration within future flight. One aspect that I want to concentrate on for this pitch is the fact that I'm conducting research into drone law as part of a PhD with Cranfield University. Next slide, please. So part of my project idea is I'm going to look at developing the legal framework for UTM. So absolutely happy to work with the CAA on the Sandbox. I did spend some time in the CAA's UAS unit, and I ratified many permissions in the UK from ground up to space. So I have good familiarity with the complex requirements that the CAA have around safety mitigation. And on mitigation, there are a number of mitigation measures that people can employ in contracts. We've heard a bit about that today. The other thing that I'd like to look at is how we can influence a change in the law, and looking at a drone bill specifically is one aspect of that, because I don't think that's very good law. What I want to do within my PhD context is come to a point where the research helps regulators make good law so that the airspace is equitable for all, which is in accordance with ICAO's UTM principle. It remains a responsibility of the regulator, but access to the airspace should remain equitable to all users. So I'm looking at case studies to conduct over the next 5 years as part of my PhD research program, and UTM platforms, complex BVLOS ops and regulators are the people that I want to work with. Thank you.
Thank you very much. Alistair Munro from Amniotics Limited.
Hello. You can read about the company details below. I'm who are we? Experts in technical aspects of aeronautical telecoms and standards, and we're a long-term member of standards bodies of various kinds and contributors to regulatory inputs. The arrow points you to a list of bodies. We heard from BSI already, but there's EuroK, which really focuses on performance and safety, bringing those together in technical specs. I'll leave you to read the other ones. Next slide, please. What's the idea? Every UAS, this is for drones specifically, needs wireless comms, mobile comms. It doesn't just lie around waiting to be taken up. It needs to be built into a performance-based standard for various kinds of use, air-to-air, air-to-ground. There's plenty of standards being developed in those areas. Where's the innovation? I think what we aim in the work I've done so far is to avoid expensive specializations, use capabilities that are there already, use spectrum models that are well understood. Services, obviously we offer the long-term experience of standards development, but I think where it's fallen down in the past is the path to success. You need confidence in a business model. You need people willing to make tangible, proactive contributions, and you need to put money and time into it long term. And that's really one of the key things that we would focus on as part of our project. Thank you.
Okay, thank you. Next up is Frank Kirkland from Queen's University Belfast.
Okay, good afternoon. I hope you can hear me. Just introduce Queen's Belfast for those unfamiliar. It's a Russell Group University with strong engineering and science background. And the engineering department there has significant aerospace experience. In particular, several staff have worked in aerospace companies before going into academia. As a research organisation, we've got strong links to industry across the UK and locally. We've got live research programmes with our partners and research organisations, as well as some internally funded projects, which can also be a really good start to a collaboration. So next slide, please. In terms of topics of interest and where we want to do research, our key strength is around advanced structural systems and subsystems analysis. There's a little cartoon on the right-hand side showing how we break down through requirements, system, subsystem, assembly level to analysis, which is key for certification and regulatory approval, as well as optimizing the design. We're also developing a capability around platform design and understanding platforms and standards. And we can link through to our Right Tech, Right Bus Centre who work on platforms there. Not directly mechanical engineering, but we have strong links to our cyber security centre. And again, we're looking at how you design and incorporate security there. So again, in regulatory terms, that's quite important. And we also have the Queen's dedicated manufacturing centre where we can rapidly prototype and develop methods. You can also see the links that we can offer locally to SMEs, design capability and regional funding agencies. And obviously we're looking for innovative challenges. Anybody who wants to minimise structural weight or wishes to develop a structural or platform strategy. Thank you very much indeed.
Oh, thank you, just on time. All right, next up is Jonathan Smith from SDFC Hartree Centre.
Hi, so what is the Hartree Centre? It's part of the Science and Technology Facilities Council, which is a part of UK Research and Innovation and one of 7 funding councils making up UKRI along with the Research England and Innovate UK. The Science and Technology Facilities Council looks after national strategic infrastructure that enables physical science research, which includes particularly supercomputing supporting facilities. It includes our subscription to Large Hadron Collider, Square Kilometre Array and that sort of thing. But what I'm trying to get across is that we're involved in the biggest of big data experiments in the world. Hartree Centre is a bit further up the TRL level and is exclusively a kind of business-focused organisation. So we try to enable, we provide at-cost access to facilities and staff to enable people to adopt these advanced digital technologies, high performance computing, big data, artificial intelligence, machine learning, natural language processing, and the like. Next slide, please. So I guess what I want to say here is really that we have a number of different key offers. One is just access to the high performance computing systems. They're some of the largest in Europe, and certainly the largest that commerce can get access to. We're experts in the scale up of existing software to those platforms. We're involved both on the scientific side as well with things like acoustic simulation for noise abatement and the like. We're involved also with cloud platforms, so we can look at either our in-house or the cloud, depending on what's most appropriate. Our data analysts can explore new regulatory models, and we're experts in natural language processing, both off-the-shelf tools from cloud providers and custom-built ones. And we've got experience working with regulations for chemistry and the like, already trying to look around Europe and see what works best in a given environment. The digital assets mentioned on the slide are things like uncertainty quantification toolkits to enable people to make, essentially put an error, a maximum error on the result of a simulation, and then run sufficient simulations with surrogates, quick surrogates, faster than a conventional model to be able to get there. And we're sort of really experienced with all of these things around other bits of SDFC. We're experienced with quantum communications, so ultimate encryption. We've got Daphne, the data and analytics facility for national infrastructure, which is part of the UK Collaboratorium for Research on Infrastructure in Cities. So we've got a variety of different offers that can be made available to a consortium at cost. Thank you.
Thank you. Next is Matthew Johnson from Marble Aerospace.
Good afternoon, everyone. So yeah, we're Marble. We provide maritime surveillance services to government and NGOs, and we do that with unmanned aircraft that we design, manufacture, and operate ourselves. So our expertise really lies in that overall system integration and on one specific type of platform, which are fixed wing VTOLs, which are obviously like convenient to use and can provide really long range. And the operation we've been doing recently has been focused in the Caribbean, and we're doing 4 deployments this year in different countries, obviously pending see how the situation evolves. And so what we've been doing so far is specializing in developing BVLOS operation in a maritime environment. So next slide, please. And so what we're interested in for this competition is to try to bring that expertise we have in other countries where they might have less restricting regulation than we have in the UK. And so we want to try to bring our expertise and put a BVLOS maritime operation in an area where it might be needed in the UK. So the one particular one particular aspect that is innovative is that we do our operation on a really regular basis, and we want to operate 24/7, which we feel that this is something that is frequently not done with BVLOS. It's frequently more like short-term deployments. And yeah, so the type of partners we're looking for are people that have UK regulatory expertise, people that have maritime testing facilities, and as well complementary partners that could work with us with the data. So for example, people that have radar installation or unmanned ships. Thank you.
Thank you. Right, next up is Andrew Staniforth from SAIR.
Good afternoon. Thank you for the opportunity to pitch. As I said, I'm Andrew Staniforth, the Director of SAIR UK. We are a safety and security research training and consultancy-focused SME based in the UK but operating at a global level. Our strategic aim is to develop the intersection between government, academia and private industry by encouraging and enhancing the development and delivery of innovative technologies, exposing them to the operational realities of real-world security challenges. Our team come from senior policing, academic backgrounds and commercial backgrounds, blending the practical, strategic, operational expertise with security research and knowledge of public bodies and private sector organisations. Our network of contacts has been built over more than 5 years of delivering complex and challenging projects. Next slide, please. Our expertise within the scope of future flight comes from a suite of research and innovation projects we're currently involved in. The first one is DroneWise. It's a European project looking at the terrorist use of drones to attack public spaces. We're working with police colleagues from Germany, Greece, Croatia, Bulgaria, and Estonia. The second project there is a DENY project, a counter-drone project examining detection, evaluation, neutralization, and identification of drones, which is training we've delivered around the world. The final project there is Skyway, currently working with Highways England and Police Scotland, examining the prioritisation of drone flight paths. I'm also the co-author of an upcoming book by Optic House, Counter Unmanned Aerial Vehicle Handbook. So finally, Sahir is seeking new collaborative opportunities to progress research and innovation within future flight, which meets our skills and expertise. We offer unique insights and alternative perspectives through challenging use cases, regulation, how enforced, underpinned by a proven track record of project management delivering positive evidence-based outcomes. We also offer outstanding training and facilitation expertise, and through our knowledge and experience, we'll amplify routes to the market, adding significant value to future flight consortiums by bringing innovation research to commercial reality. Thank you very much.
Okay, next up is Suj Kerr from Houndstooth Wireless. Do we have Suja? No. Okay, doesn't look like Suja's there. So let's move on to Chris Probert from Welsh Government then. When you're ready, Chris.
Hi, can you hear me, Michelle?
Yes, perfect. Thank you.
Okay, great. Thanks, Michelle. Good afternoon. So for those of you that were at the use cases event last week, this slide is actually the same. So just a quick recap. We are an agile and well-connected organisation. Our devolved areas include economic development, transport, and local government, I think all of which are meaningful in the context of future flight. We are experienced in working with both industry and academia in many sectors, and including aerospace and aviation, and actively support R&D, inward investment, and export. Next slide, please. At this stage, we are open to hearing from individual companies or consortia about their plans. If we can see mutual benefit in developing a proposal, we will be happy to work with you and to explore your project. It was interesting to hear both Chris Reed and Gareth Watmore talking earlier about the broader regulatory landscape, and taking the example of planning. This is an area in which many aspects are devolved to Welsh Government. If, as discussed in all of these sessions, you see early adoption for your idea in a rural setting with the potential to address societal challenges in unique and compelling ways, then the Welsh Government in Wales could provide the solution to many of your needs. The Welsh Government owns both Cardiff Airport and the Bro-Tartan Complex, and is well connected with the owners and operators of all other airports and airfield assets in Wales. So as we all look to phase 2 of the Future Flight Challenge, we are ready to play our part in projects that can leverage our physical, government, and industry assets. Thanks very much.
Oh, right. Thank you very much. Right, so Suja is apparently here. Can we go back and try again? Are you there? No. Hello? Looks like she's gone again. Okay, hang on a sec. Let's okay. All right. Well, let's move on to Andrew Chadwick at the Connected Places Catapult. Thank you, Andrew, when you're ready.
Michelle, thank you very much indeed. Hello, everyone, wherever you're in the world. I hope you're all safe and well. So the Connected Places Catapult, we're one of 9 catapults within the UK. Our focus is around transport and with people and places and how they're connected. So we have a strong record of working with government and industry on unmanned aviation projects. So we lead the government drone Pathfinder program. We are running the National Open Access UTM framework, and we're a member of the Drone Industry Action Group. So we have expertise in transport models and decision making, unmanned aviation, including UTM and BVLOS operations. We have market sector knowledge. We have knowledge of transport infrastructure and planning, and also on human factors. Michelle, next slide, please. So our project idea is the development of a seamless, sustainable and connected transport system with aviation at its core. So this is a new approach to addressing transport connectivity. So the services that we offer are centered around three aspects for this particular program. So on UTM is using our open access UTM framework, so using that for baseline for all UTM trials, demonstration of regulation and certification, and the technical architecture and the protocols that we've developed within that framework. Indeed, the new white paper for that framework will be released in May, and we'll be having a webinar to launch that. So watch out for that, please. BVLOS, we have a number of use cases and lessons identified from the Drone Pathfinder program, including market requirements, the analysis, and the use cases for technical services. And we're involved in their technical management and program management. And finally, on the future air mobility side, so this could also be urban air mobility or around the rural areas. We have expertise and experience recently in market and demand modeling, and how we integrate with other transport modes and infrastructure, both physically, digitally, and from an energy perspective. We're strong also in public engagement, use cases, and business case aspects of aviation. Thank you.
Okay, next up is Elizabeth Teal from Samad Aerospace.
Hi, Michelle, can you hear me?
Yes.
Good afternoon, Elizabeth Teal here from Samad Aerospace. We are leading a proposal to develop the vision, roadmap and operational model for the future flight of a sub-regional VTOL flight operation that delivers significant time saving to the end users and benefits environmental concerns by increasing transport efficiency. As part of this proposal, we will provide all of the necessary test beds and ultimately one prototype of our main aircraft, the Starling, in phase 3 for demonstration. What's more, on the support side of things, we can also make a range of vehicles available for other proposals. Samad Aerospace has successfully developed a number of subscale demonstrators towards our Starling demonstration. These range from 10% to 50% scale and have allowed us to explore flight characteristics and flight control. And we have found the opportunity to spin out some of these as commercial products. We are very pleased to announce that the 20% scale drone, known as the S2P, is now commercially viable. What's more, Samad will very soon be flying its 50% scale demonstrator, the S5, which accelerates the path to the Starling certification. Next slide, please, Michelle. This table presents vehicles we can offer to partners looking to submit future of flight applications. Top left, the S2P offers one of the longest range performances of any VTOL UAV. We are yet to develop BVLOS capability and therefore interested to talk with the companies that have. Production readiness is expected later this year and will go ahead hand in hand with CAP 722 certification. Top right is the unmanned S5U that will fly later this year, and the manned version, bottom left, is scheduled to fly under experimental license in 2022. Lastly, bottom right, we include the Starling itself. For this vehicle, we are looking for partners who are interested in system of systems and operational aspects. If you want to know more, please get in touch. Thank you.
That's great. Thank you very much. Okay, so next up, we've got Nigel Hewitt from Osprey Consulting Services. When you're ready.
Can you hear me?
Yes, I can hear you.
Good afternoon, everybody. Nigel Hewitt from Osprey Consulting Services, and I lead the Platform and Air Systems team. As a bit of background, Osprey is an independent aviation consultancy, and we pretty much span almost every aspect of aviation. Some of the broader things we do are airspace design to the CAP 1616 process, safety cases for both systems and airspace, and that can include air traffic management systems, manned and unmanned air systems certification airworthiness, and we're currently working with the Welsh Government to help them navigate through the regulatory process and the influence emerging technologies and processes. Next slide, please. One of the products that we offer is something called Ether. It's a service we offer which has its derivation in work that we did for a high altitude pseudo satellite in developing a safe separation assessment. And it basically offers a number of features that result in dynamic risk assessment based on operating strategy, regulatory approval, risk assessment, company and industry policies, and forming the ConOps. So I think it's really a good tool for the future flight concepts in everything that's coming together, where we'll be able to manage that. It's modular in construction and can be adapted across a number of pieces. Thank you very much.
That's great, thank you. Well within time. Next up is David Youngs from LiveLink Aerospace.
Good afternoon, everyone. Hang on in there, very nearly to the end here. So quick company background. I'm the co-founder of a LiveLink Technology Group. I've been running for about 10 years, classic student loan garden shed startup, but we've somehow without VCs got to 100 staff and 4 offices across the world, and have been working in stealth mode in the aviation unmanned sphere for 3 years now. I'm a rotary and fixed wing pilot and find this whole sphere fascinating. The particular problem we're trying to solve is safe, routine, high density, and in particular profitable operations, because all of these ideas are great, but ultimately they will only persist as long as the money does. And so we're trying to look a little bit further down track and what's necessary for people to actually have a scalable operation. The particular thing we're focused on is the requirement for detect and avoid. And that involves both uncooperative traffic, the mixing with GA, but also fail-safe. So if all of the cooperative systems were to have an issue, what happens next? Next slide, please. Our solution is a micro radar-like system. We've got a range well ahead of 1 kilometer, but we can easily show you 1 kilometer. And this is very small. It's got an FPGA. It's got small solar powerable systems on board. So one can put these out there with minimum infrastructure, minimum cost, and a very high degree of resilience because of the number that one can spread. You can literally put them in a field with some solar panels and no other infrastructure, and they will work. The collaborations that we think could be of particular interest. Firstly, if somebody out there is looking to do something and they need to improve their safety case, particularly as one edges in towards the urban area. Secondly, to enable operations and have a safety case that would otherwise struggle if one couldn't assure the absence of other aircraft, manned or unmanned. Thirdly, if you're looking to save money versus conventional radar or conventional human surveillance. Fourthly, a communication systems of last resort. If one is designing a high density area and you're relying on some form of communications backbone, our PDAR units have the capability to also take and channel messages further down the roadmap, which could make the difference for a high density environment if there was to be a comms problem with 4, 5G or similar. And then finally, the capability to take some of this technology and put that into a flying system so that for an extended range, one could have an additional detect and avoid capability. So any interest, any questions, do please drop us an email. Thank you.
Thank you. Next up is Soraya Abdul Rahman from University of Sheffield.
Hello.
Hello.
Hiya. Okay, so good afternoon, everyone. My name is Shahira Abdurrahman. I'm a research associate at the Innovation Caucus, and I am coming from a rather different angle from all the pitches today, as I am an academic, and I'll be pitching my project today in hopes to get you interested in participating in it. I'll first give some background on the Innovation Caucus, where I'm working at. It is a UK-wide collaborative research group, which is jointly funded by Innovate UK and the Economic and Social Research Council, and based at the University of Sheffield. We focus on research supporting sustainable innovation-led growth by promoting engagement between the social sciences and the innovation ecosystem. So I'll get straight to what my project is about in the next slide, please. So the aim of my project is to explore the dynamics of standards, regulation and trust in new markets. The areas touched by future flight is the perfect arena to do this. In new markets, there is a concern about finding the right balance between regulation and standards in a way that would not hinder, but instead enable and encourage innovation. In these dynamics, I believe that trust, whether between the different stakeholders involved in the challenge or trust of the challenge itself by the public, can affect how we set regulation and or standards. Knowing these dynamics in unique and in-depth case studies can really give us insights into improving collaborative practices and their impact to innovation and productivity goals of the challenge and the stakeholders involved. Now, my pitch here is that I am requesting for participation in my project, especially from commercial partners, to gather these insights through interviews. I'm hoping that those who are listening today, if you're interested to share your thoughts on the subject, that you contact me on my email for an interview. It will only take around 60 minutes of your time, and I'll be more than happy to share my findings with you. This is a unique project, and I'm very excited about it, and even more so for your participation. Thank you for listening to me today.
Hang on time, thank you. Okay, so that's the end of the schedule. What we're going to do, we think Sue just found some audio, so we're just going to flick back to her slides, and hopefully she has some audio.
Hello, can you hear me?
Hello.
Thank you so much, Michelle and team. Thank you. Hello, I'm Suja. I look after the partnerships at Houndstooth Wireless. We're a small technology startup company. And over the last 2 years, we've developed a drone detection solution that detects, identifies, and tracks both drones and controllers based on their RF signatures. In further developing our technology, we've really been very lucky in receiving one of DFT's T-Trig Innovation Awards at the moment. Next slide, please. Thank you. In terms of our project idea, it's to use our drone detection technology to support beyond visual line of sight operations of worker drones, and also to use our technology for operational surveillance of drone flight corridors to monitor flights as part of UTM solutions. In essence, this means that enabling end users to both detect, identify, track piloted drones and controllers from either detection sensors that are mounted on the ground or detection sensors that could be mounted onto the drones themselves. So our detection sensors use low power, including power over the Ethernet, are small and lightweight and designed to be cost effective. So these low footprint features make our technology particularly suited to the Future Flights project. We can offer our current solution. Each of our sensors has an omnidirectional range of up to 500 meters, which offers flexible networking, power, and communication options. And our team can also engage with partners and can provide bespoke R&D related to drone detection. We very much look forward to connecting with partners and consortiums that have a need for RF-based drone detection, both to support future flights, BVLOS needs, and also for UTM system solutions. I'm available this afternoon for Mojo meetings at any point by email. Very much look forward to speaking to you. Thank you.
Okay, thank you. That was well in time.
Thank you so much.
No problem. Okay. Well, that was the last pitch. And we'll come to the close of our session. I just want to, if we can give a virtual thanks to all our speakers today for contributing to this regulation-themed session. I just want to highlight that as a team, what we're doing to support Future Flight Challenge going forward. We've got a whole programme of work that we're going to be delivering to support the challenge, all around building those networks and building those disparate communities and technologies and sectors that are required in order to create that future aviation system. So, and part of that, we want to run what we're calling Future Flight Fridays. So this is a monthly webinar. What we'd like to do will be very short. It'll be 12 p.m. on the lunchtime, have a sandwich, sit in, and it'll only be 40 minutes, absolute max. And there'll be various formats. I've got colleagues across KTN working on this, so there'll be panel discussions or presentations and things like that. But if you want to give a 10-minute presentation, you're more than welcome. It's about picking a Friday and letting the team know at Future Flight. We want, so as it says there, the aim is we want to highlight this UK expertise in order to build these consortia, and we want to sort of enable those new collaborations and readiness for Future Flight and 2024. That is just building that expertise in order to deliver that. So on that, if that's something that you want to participate in, please do get in touch. So this is aimed, if you're a phase 1 winner, you're looking for expertise, this is your opportunity to showcase your project, your idea, what it is you're looking for. It's also an opportunity, Gary's already communicated, he's given you a snapshot of what's coming for phase 2. You've got the themes, you know that anybody can lead on these applications for phase 2. So whilst the phase 1 applicants, yes, they've had a bit of a head start since February, on building that consortia, but this is your opportunity to expedite that and as well and catch up, and you can use this as an opportunity to build your consortia as well if you want to lead on a project as well. So and also academics, more than welcome if you want to join a consortia. This is your opportunity to showcase your expertise, and also if you've got unique facilities as well, and we've heard about some of them today and in previous sessions, it's an ideal opportunity. So just wanted to flag that up. So I guess it just remains to say from me, a thank you very much for joining us for these. If you've joined all 3, brilliant, but definitely for joining today, particularly in these challenging times. The delivery format for these events is being highly experimental. So this is the first time that we've actually delivered the presentations through Zoom, but live streamed it on YouTube. So I just want to thank very much to Ash and Sarah from Visair for their support to enable us to do that. We are constantly learning at KTN, and moving forward, we want to improve our online delivery, and particularly during this time of social distancing. And also thank you to Natasha, the events manager at KTN, is working with me on this Future Flight programme, because honestly, she has to do some serious multitasking through this session. So thank you very much, and all your support in bringing all this together. Thank you also, Simon, for your facilitation on YouTube with the questions. So as I said, I will be following up very soon with details for the phase 2 of the competition when it's available on the IFS Innovate UK. Thank you very much for joining us, and wish you farewell.
We need to be bringing together people with expertise in airspace management, airframe manufacturers, artificial intelligence expertise, and also it's about the infrastructure, the digital and physical infrastructure that are required in order to deliver this future aviation system. KTN is very well placed in order to bring all these different stakeholders together.
We're going to have to adopt innovative and new ways of moving people around. So this is a really good opportunity to get the really good ideas that are out there about different ways of delivering that aviation infrastructure.
We in the UK have an awful lot of talent that the UK has invested in, and we are pulling this all together. So lots of different technologies, lots of different facilities, and lots of people from many different disciplines. And we are going to create a next generation capability that is greater than the sum of its parts. That is so exciting.
The challenge is working as an enabler for the future generations, not just myself, my children's children and beyond, and how we're going to impact things on much a grander scale than we can even imagine. And we're bringing together so many different businesses, industries and areas of technology that we didn't even think would need to work together, creating a new story for us all. So that's really exciting.
For me, the most exciting aspect of the Future Flight Challenge is the opportunity to bring together a diverse range of innovators, people who wouldn't normally talk to each other across many different industrial sectors, and to get them to work together towards our overall objective. The single biggest hurdle that needs to be overcome is getting the right people to be working together, which I think the Future Flight programme is admirably making an effort to do. The technical and engineering expertise in the UK makes us very well positioned to take an international lead in this space.
The most exciting dimension of the Future Flight Challenge for me is learning about the new technology, but also providing a user case to many of the people that I've met here, because I'm very interested in using drones to deliver medicines. And the thing that really excites me is the ability to precisely deliver something, but also to deliver that in a timely and safe manner.
So the most exciting dimension of the Future Flight Challenge is probably by far the scale of the program, the breadth of innovation that it brings together, and the fact it brings really the best of innovation in the UK all together.
The approach that we've taken in Future Flight, and one of the things that we see as quite challenging, is we've not pre-decided which future aircraft is the right solution. We've kind of left ours quite open and said the types of aircraft, the timing of them and how they fit together, we're open-minded about. So for us, there's a great degree of innovation and some risk involved in saying we don't know the answer, we're going to be very broad-based, we're going to support people across that spectrum, and we'll kind of see what emerges. So there is a little bit of we try things, we learn and we move on, rather than have a really prescribed programme.